Hey guys, welcome back to a new complete game tutorial video where we are going to make this 2D platformer game inside Unreal Engine. So this game is going to be similar to Doodle Jump where you have to jump on the platforms and keep going up. Higher the player goes, more score he achieves. And it is going to be a fun, simple and easy to play game, and that's exactly what we are going to build in this video. It will be a simple 2D game which will teach you a lot about making games in Unreal Engine. Since we are going to make different kinds of mechanics in this game, like a custom jump system for the player, which also you can tweak on your own, then procedurally generating platforms which makes the game run endless, and the platform gaps and variation will keep on changing based on the difficulty level. And many other mechanics like score system, player fall animation, save game, gyroscope movement and many more. And it is going to be beginner friendly tutorial, so if you are new to Unreal Engine, you can still keep up. And this video is a compilation of all the videos of 2D platformer series, so you can also watch videos in parts if you want to. The playlist link will be in the description. Now before we continue, let me tell you, you can download this whole project from my Patreon or Gumroad, so that you can directly get the build project that you can modify according to your style and then publish it wherever you want. And it will also support me to keep making such tutorial videos, and I wanna thank my Patreon supporters. Thank you so much for your support, it really means a lot. Alright, so now let's get to the video. So I'm here in my Epic Games launcher, and the first thing we are going to do is we are going to create the project. And here I'm going to use Unreal Engine 5.7. You can use any version of Unreal Engine 5, doesn't really make a huge difference. Let's launch the engine. So once it open up, from here let's create a new project. And from the games, here select the blank template. Since we are not going to use any template to make this game, now here keep this option to blueprints, since this is the language that we are going to use to build logics in our game. And the target platform, you can keep it to desktop, doesn't really matter, you can still build this game for mobile. And here keep the scalability to maximum. Now from here you can change the location where you want to keep this project in your computer. And now let's set the project name. I'm going to name this Doodle Jump since we are making a similar game to this. And now let's click on create. So once your project opens up, here you'll see it comes up with this default map, but we don't really need this map. So from under the file, here let's create a new level. And we are going to create an empty level. So select this and create. So here as you can see, this map is completely blank, and this is where we are going to set up all of our things. But before we do that, first make sure to save this map in your content browser. And here first I'm going to create a new folder just to keep things organized. And inside this map folder, let's save this map as playmap. So in your content browser, you can see this map is now saved. And now what we are going to do is, here let's create one more folder and let's name this assets. And inside this folder, we are going to keep all the assets that we are going to use in this game. Now the main assets that we need for this game is, first we need a background image. The second thing we need is a character image. And the third thing we need is our platform images. Now to get these images, you can either go to Google and search for these images. Like first one, we need 2D game background, and here you will find a lot of images that you can use, or you can just go to some websites where you can find these assets for your game. And the second option we have is that we can generate these images using AI. So that's exactly what I'm gonna do, and the AI for this I'm gonna use is ChatGPT and Gemini. So first of all, here I am on ChatGPT and we need a background image for a game. So I'm going to give it prompt like, hey, I'm creating 2D game similar to Doodle Jump. So I need a background image for the game. Create one. So now it will generate a background image for a game. So let's see what it come up with. And there you can see it is a background like Doodle Jump Game, but still it's quite distracting with a lot of unnecessary arts, and we just need a plain background. So let's improvise a little. So make the background plain, without any clouds or any other art, just simple square blocks. Alright, so this is exactly what we want. So just make sure to save it. And now we need to generate platform images. For that, we are going to use this prompt that says, since there are going to be different kinds of platform in this game, generate normal platform image, different than the original Doodle Jump game, but that also suits the background. So there you can see it came up with this platform image. So let's download it from here. And now we need to remove the background from this platform image. So to do this quickly, you can go to any image background remover website like this one. And here you can just drop the image. And this will remove the background from your object. And then make sure to download this image. There you can see it is so clean. Now the same way we are going to generate the next type of platform that we have, which is a breakable platform. So now just tell it to generate breakable platform. So this is what it has came up with. Now when a character will jump on this platform, it is going to break. So we need its broken image too. So for that, I'm gonna give it this prompt, which says, now make its break image where these two pieces tilts down to show them as they breaks from between. How is this possible? What the hell? I think something's going wrong with this AI. So let's make some change in a prompt. Oh, now I understand. Anyways, we got the result as intended, and finally we need a moving platform. So let's give it a prompt like, now make the moving platform for my game slightly different from both of the previous platforms. So here it has generated the moving platform. So just make sure to save it. And now we need to generate our character. For that, I'm using Gemini since I have reached my limit for image generation. So yeah, so let's say it like, hey, I wanna create a platformer game. For that, I need a 2D adventure character. So create one. So once you get your character image, then you can tell it to remove the background and place the character in the side view idle position. So once you get your image, make sure to save it, and now we need a jump image of this character. So for that, tell it to make jump animation posture for this character. There you go, now we have a jump posture for this character. Just make sure to remove the background from all of the images that we have generated so that we can use them in our game. So here I have all the images that I have generated for my game. My asset images are a little different because I generated them beforehand, and I just showed you the demonstration how you can generate your own assets. So yeah, now it's time to import all of these assets into Unreal Engine. So here just drag them here, and now all of the assets are imported. Now select all of them, right click, and from sprite action create sprite, and now it will create a sprite for each of these images. And these sprite assets are the one that we are going to use inside our blueprint classes. Now one thing you need to do for each of these sprite is just open them up, and we need to remove the collision from each of these sprites. So for that, from here click on edit collision, then select the collision and press delete. We do this because we don't really need a blocking collision in any of our assets, and we are going to create collisions of our own later on, so you can just delete these default collisions from each of the sprites. So when you're done with all of these sprites, then let's organize these assets into folder. So let's create a new folder, and this folder is going to be for platforms. So just select all of the platform assets and move them into this folder. Similar way, create one more folder for the background and move the background assets into this folder. And one last folder I'm gonna create for the character. Just move the character assets into this folder. So now as we have organized the assets into folder, now let's come back here, right click and create a folder, and let's name this blueprints. And inside this folder, we are going to keep all of our blueprint classes. Those contains the logic for the game. And inside this, let's create a folder and name this background. And inside this, right click, create a blueprint class of actor type, and let's name this background BP. Open this up. Now inside this blueprint, we are going to set up the background of our game. So for that, first here let's add a paper sprite component. Here it is, selected, and now from the details panel, from here you can just select your background sprite. There it is. Now let's scale this down a little, like 0.65, like this. Now after this, we are going to add a camera component through which we will be able to see the game from this front perspective. So from here, add a camera. Here it is. Now just rotate the camera so that it will be facing towards the background, and move it a little backward like this so that we will have a nice view. And now we want to switch a player's view to this camera so that we will be seeing the game from this perspective as soon as the game begins. For that, here come to event graph, and here on the event begin play, which fires at the very starting, we are going to switch the camera view. So to do that, first get player controller, then from this search for set view target with blend. Here it is. And now we need to provide it the new view target, which is going to be this blueprint itself. So here just give it the self reference, like this. Now we also need to change aspect ratio of this camera, which we cannot edit from the details panel, and this default value is for text of wide view. But since we are making it for mobile and we will be playing in portrait mode, so the screen will be vertical, and for that we need a different aspect ratio. So to change its aspect ratio, get the camera component, and from this search for set aspect ratio. Now the exact value you need to use is 0.5625. So now let's compile, and now it's time to place this background BP into the level. So just drag it into the level, and here just make sure its location is at 0 in every axis so that it will be at the center point of the world. So now let's play. And there you can see, we can see the game background properly, but there are still a lot of issue with this. Like you can notice the colors are not accurate because it's a 3D engine, so all the lightnings are working like a 3D engine, and we need to fix that. So for that we need to change some settings from project settings, but before we do that, here under the edit, go to editor preferences, and here set the asset editor open location to the main window, so that whenever you will open an asset file, it will automatically attach with the main window instead of popping out like this. Now the next thing we're going to change is under the play. Here we can change the viewport resolution. So by default it's for normal desktop, but if you click here, now the viewport size will be portrait. So here if we play, you can see now the viewport size looks more similar to mobile devices. Now if you are getting these bars at the corner, then you can just go to your background BP, and here you can just adjust your camera location, adjust the camera a little closer. Now you can see it's covering the background perfectly. Alright, so now we need to fix the lightning issue so that we can get proper 2D graphics. So for that we need to change some rendering settings. So under the edit, go to project settings, and here first of all search for lumen. Since it is going to be a simple game, we don't really need lumen for this project. It's a very advanced method of rendering lights in the scene. So just turn it off, and also from the reflection, turn off the lumen. Then search for shadow maps and change the shadow map method to shadow maps. And then search for anti-aliasing method. Now this thing decides how pixels are rendered on the edge of the object. So this TSR method will make the pixel look very weird at the edges. So you can change it to FSAA or none. After this, search for ambient occlusion and make sure to turn them off, since we do not need any internal shadow or something. Now after this, search for forward shading. Now you can enable this option if you're planning to make this game for mobile devices, because forward shading is a rendering technique that is more optimized for mobile devices, but I'm just going to keep it disabled for now. Now with all this, our project is more optimized, but still there is not enough difference visually. So now we need to add a post-processing volume. Now this post-processing volume is just like adding filter in your game. Just like you add filters in your photos, it works similar to that, and the area that covers inside this volume gets affected with that. Now first of all, in its details panel, search for unbound, and now check this option. We enable this so that whatever the settings we will change for this post-processing volume, it will be applied to the whole world instead of just the area inside this volume. Now after this, search for EV, and under the exposure, here check this min EV100 and max EV100 option and set both of these values to 0. So now it will log the exposure of the lightning. And there are some settings that I forgot in the project settings. So let's go back to project settings, and here search for motion blur and make sure you disable this since we don't really need it. Then search for auto exposure, and here just disable this. And also set it to manual. And now if you play, you'll see it is too bright. So here you can just change its value to 0. Now let's play. It is now looking fine. Now there are some more settings that you need to change in your post-processing volume. So here search for vignette, and from here check the vignette intensity. It is actually black shadow effect at the corner, so we don't want that. So keep it to 0. Now the next thing we need to search for is tone curve amount. So enable this and set it to 0. And then finally search for expand gamut and also set this to 0. So now let's play, and there you can see now the background is actually looking like it should be. Now even if you compare it with the image side by side with rendered scene, you can see now they look quite similar. Maybe it needs a little more exposure. So in the project settings, from the auto exposure, let's set the value to 0.5, and now it's perfect. And now what we are going to do is, we are going to create a start menu where there will be a start button right here at the bottom. So when we click on it, then we can actually start the game. So let's quickly go to your content browser, and here let's create a folder. Let's name this user widget, and this is where we are going to keep all of our UI. Now here right click, and under the user interface, here let's create a user widget. Let's name this start menu UI. Open this up. Now first of all, let's add a canvas panel. So this canvas panel is for the desktop view. So from here we are going to change it to custom. Set the width to 720 and height to 1280. So now the size is in the portrait size. Now from here search for button and drag it into the canvas panel. Now place the button at the bottom and let's resize it a little so it will be wide enough for the text. Now from the background color you can change its color. I'm going to set it to green. Now from here let's add a text and drag it inside the button. Let's set the text to start, and also from the font, here let's change the font size to 50. And at the last, select your button and make sure its anchor is at the bottom so that your button will stick on the bottom side of the screen. And now we want to display this widget at the very starting of the game. So to do this, first of all we need to set up a game mode. For that, come to your world settings. If you don't see this tab, then under the Windows, you'll find it here. So in your world settings, currently we do not have any game mode. So we are going to just make one. Just click on this plus button. Now here we have to tell its location where we are going to create this game mode. So under the blueprints folder, here I'm going to create a new folder and let's name this frameworks. Inside this folder, I will keep all the basic frameworks of the project like game mode, player controller, and all those things. Now I'm gonna name this Doodle Game Mode. Click OK. Now here make sure you select the game mode that you just created and then let's browse to it. Here it is. Now let's open up this game mode. Now click on open full blueprint editor and here on the begin play, which will fire as soon as we open up this level, and that's when we are going to create this widget. So here search for create widget and from the class select the start menu UI. Now right click and promote this to a variable. Name this start menu. We are storing the start menu reference just so we can make changes in this later on, like removing the widget. And then add to viewport. Now after this we are going to execute one more thing. For that, hold the S key and just click, so you will have this sequence node. So here we will first execute creating the widget, and after this we want to change the input mode to UI. For that, first we need to get the player controller, and now from this set input mode to UI only, since we just want to focus on the UI. Now from the player controller search for set show mouse cursor and make sure to set it to true so that we will be able to see our mouse cursor, just so we can click on the button. And now let's play and test this. So as you can see, we have start menu widget on our screen as soon as we play, and now we just need to start the game when we click on the start button. But that's all for the another part. Now before we continue, I forgot one thing from the previous part, that we have to set this map as a default map so that whenever we open up the project, this level will open up at the start. So under the edit, go to project settings. In the maps in mode, here set the editor startup map to a play map and do the same for the game default map. Okay, so now we have to create character blueprint for our game. So here first let's create a folder where we are going to keep our character blueprint, and inside this right click and we are going to create a blueprint class. Now here from the all classes search for paper character. So it is going to be our 2D character. Let's name this Doodle Character BP. Now let's open this up. Now here from the sprite component, here we want to select our character sprite, but it needs a flipbook. A flipbook is basically collection of sprites so that we can have animations. But we are just going to use two different sprites of our character. So we are just going to create two separate flipbooks for both of these sprites. So just right click on the sprite and create a flipbook. Do the same with the jumping sprite. Now select the character idle flipbook and select it here. And that's what we are going to use as a default pose for our character. But it is quite big in size, so we need to fix that. So for that, here go to sprite asset of your character and here you'll find this pixel per unit. So let's change this value to default, which is 2.56 in my case. And this is going to reduce the size of your sprite, as you can see here. Now do the same with jump sprite of your character. Now the character sprite is still quite big, so now we can scale this down from here, like this. And now we need to adjust the capsule size according to the character. So let's set the capsule height to 45 and the radius to 25. So now the collision fits the character. Now just move down the character slightly like this, and now it's perfectly fine. So now we are done with setting up the character. Now if you play, as of now we have the start button, and when we click on it, then we want to spawn the character and start the game. So for that, let's go to the start menu UI, select the start button, then scroll down here, and here, okay, first we need to check this is variable option. So now we can add this on click event, and this on click event will fire as soon as we click on the button, and that's when we are going to spawn our character and start the game. And the things like spawning the character and doing a lot of other things along with that, we are going to do all of that in the game mode. So when we will click on the button, then we need to communicate with our game mode to call an event or something that will execute all of that. So for the blueprint communication, we are going to use blueprint interface. It's a better way to communicate between blueprints which does not require a hard reference. So I'm gonna create a separate folder for that where we are going to keep all of our blueprint interface classes. Now inside this, right click and under the blueprints, create a blueprint interface. Let's name this game mode pp interface. Now open this up and let's name this function game start. Now we are going to define this function inside our game mode, and for that we need to link this blueprint interface with our game mode. So come to the game mode, and here from the class settings, from the implemented interface, here search for game mode interface which we just created. Here it is, now compiled, and now from the interface, you'll find this game start function which you can double click, and this is going to create an event inside which you can define your logic. And this is just going to work like a custom event, but we don't need any hard reference to call this event. So in the start menu UI, when we click on the start button, then we are going to call this game start event. And here for the target, we don't need any hard reference. We just need a valid reference of the class where this event is defined, which is game mode in our case. So we can get game mode and plug this to the target. So now when we click on the start button, it is going to call this game start event in our game mode. So when the game starts, then we are going to spawn our character. But before we do that, first we need to remove this start menu UI which we created earlier. And to remove it, we have its reference stored in this variable. So just get this start menu reference, and from this search for remove from parent. So this is going to remove our start menu UI on the game start. And after this, we are going to spawn our character. So search for spawn actor from class, and from this search for doodle character. Here it is. So it is going to spawn our character in the level. Now here from the spawn transform, right click and split the structure. So now we need to provide it location, rotation and scale to spawn our character in the level. But mainly we just need to provide it the location. So in the level, we want to spawn our character somewhere right here. But for that, we need to have something right there to pick up the exact location value that we can provide to our character when spawning it. So for that, in your content browser, let's create a blueprint class that we can place in the level to use it as the start location for our character. Now let's open this up, and here I'm just going to add an arrow component just so we can know in which direction it is facing. Now let's place this blueprint into the level wherever you want to spawn the character. You can also adjust its position from the details panel, where I'm going to keep its Z value to -300 and then X and Y value to 0. Now here you can adjust its Y location slightly forward like 0.1 so that your character will stay a little forward so that it won't overlap with the background. Now just rotate it to make sure it faces in the forward direction in the Y axis. And now we are going to use its world location from the level to pick the spawn location for our character. So for that, here before we spawn our character, here search for get actor of class. And from here search for your starter BP which we just placed in the level, and this is going to find our starter BP from the level so we can get its actor location and then use this location to spawn our character. And after we spawn our character in that location, then just right click here and promote this to a variable so that we can store the reference of our character in a variable which we might use later on. And now we need to possess to our character so that we can control it. So for that, get player controller, and from this search for possess. And the pawn that we want to possess to is our doodle character. And just after we are done spawning our character properly, then we can just destroy the starter BP from the level. So here just search for destroy actor, since we do not need it anymore. Alright, so now let's play and test this. So here as we click on the start button, so we are having an issue here. The problem is that once we spawn and possess to our character, it will try to switch our camera view to our character blueprint. But we don't really have a camera component in our character blueprint, and we just want the camera view to stick to this background BP. So we are going to switch our view back to this camera in the background BP. So here come back to your game mode, and here after all this, get actor of class, and here we want to get reference of our background BP so that we can switch our view back to this blueprint. So for that, get player controller, and from this search for set view target with blend. And the new view is going to be this background BP. So now let's compile and test this again. So let's press on start button, and there you can see our character spawns and it falls down due to gravity. So now it's working fine. So now let's go to your character blueprint and select your character movement component, and from here let's set the gravity scale to 0. So now if we play, you can see no gravity is affecting our player. And now we are going to create our own gravity effect on this character instead of using the default one. We do this because we need a linear force which will pull our character downwards, because the default gravity is so inconsistent and it can affect our character movement. So what we are going to do is, on the event tick which fires every frame of the game, we are going to use this event to constantly pull the character downwards. Now first of all, we are going to create a boolean variable. Let's name this gravity. Now compile and set the gravity to true by default. Now here get the gravity variable and use a branch to check if it is true or false. Now till this gravity variable is true, then we are going to keep moving this character capsule downwards. And if this gravity boolean is false, then it will stop moving the character downwards. So this way we can control gravity using this boolean variable. Now to pull the character downwards, get capsule component, and from this search for add world offset. Now right click and split the structure so that we'll get each axis separately, and now we just want to add value in this z axis so that we can move the capsule downwards, and the value that we are going to add is going to be -14. You can always experiment with the values, but it just works fine in my case. And if we play, you can see it pulls our character downwards. Now since we are doing this every frame, the speed of character going downwards can differ from device to device depending on the frame per second. That means higher the frame rate you are getting, faster your character will go down. And if you are getting low frame rates, your character will go downward slowly. And to fix this issue, we use delta seconds. Now this delta seconds is the time between the previous frame and the current frame. So if we use this value to move our character downwards, then it will be consistent for every device. So here if we multiply this value with 60, then it is going to give us value of 1, since this game is running on 60 FPS. So just to show you, let's print it. So there you can see we are getting 1 value every frame, since it takes 1 second to cover 60 frames. Now we can use this value to apply the same value we were using to move our character downward, which was -14. So if we multiply this value with -14, then it will be -840, and this value we can use on the z-axis, which is going to be -14 consistently every frame. So now if we play and test this, you can see we are getting the same value consistently every frame. Now in the next part, we are finally going to work on our character movement, where we are going to make our custom jump system for this character, and also we are going to set up inputs for our game. Alright, so now we need to add inputs so that we can control our player. So for that, come to your content browser, and here let's create a separate folder for our inputs. Now right click, and under the inputs, let's create an input action. I'm going to name this IA_jump. Now open this up, and here just make sure that the value type is boolean, which just means it's going to tell us if the key that is assigned to this action is pressed or not. Now the same way, let's create another input action, and I'm going to name this one IA movements. Open this up. Now from the value type, set this to axis 1D. We did this because for the moment, it is going to be either left or right. And this float axis value will go -1 on left and +1 on right. Now right click, and from under the inputs, let's create input mapping context. And I'm gonna name this IMC default, since it is going to be default input mapping for our project. And from here we can add input mappings. So let's add one. Now from here, first we are going to select this IA jump input action, and from this we can assign it a key. So for the jump, I'm going to assign it spacebar, and I'm going to assign one more key that is going to be W. Now let's add one more input mapping. So it is going to be for IA moment. Now here let's assign it key. So the first one is going to be for A and the second key is going to be for D. Now for the A key, here we are going to add a modifier which is going to be this negate, and this is going to give us negative access float value, while the D key will give us the positive one. So this way we can differentiate between left and right movement. Now here you can uncheck this for the Y and Z axis since the horizontal movement is going to be in the X axis. So now we are done setting up the inputs, and now it's time to call these input actions into a character blueprint. So here first let's search for IA moment. Here it is. Now when we keep holding any A or D key, this trigger pin will fire constantly, and that's when we are going to add movement input. And here we need to provide it the scale value, which we are going to give it from the action value, which is going to be positive or negative based on the key we have pressed. And for the world direction, the character is going to move in the x-axis, so just give it the value of 1 in the x-axis. So that was for the left and right movement of the character. And now for the jump, here just search for IA jump input action event. Here it is. Now in this, we are going to use this started pin, which is going to fire once we press the spacebar or W key. And it is not going to keep firing constantly like it does in the triggered pin. So we have to press the key again and again to make the player keep jumping. Now when our player will jump, then we are going to change its flipbook to this one which we created in the first part of this series. So to change to this jump flipbook, here get the sprite, and from this search for set flipbook. And here just select this character jump flipbook. Now after this let's add a timeline. And let's name this timeline jump timeline and make sure it play from start. Now inside this jump timeline, we are going to assign the values which will decide how long the jump will be and how much time the jump will take. So for that, first double click on the timeline to open this up, and from the track, let's add a float track since we want the values to be float type. Now let's right click and add a key. So for the first key, we are going to assign it the time and value both to 0 since we are just starting to jump at this point. Now let's add another key, and after 0.25 seconds, the value is going to be 0.8. Now let's add another key, and here the time is going to be 0.75 and the value is going to be same because the player is going to float in the air for some seconds, so the value remains same. And then at last, when the time is 1 second, the jump completes and the value comes back to 0 so that our player will land. Now right click on the key and select user. So this will allow you to create smooth curve for these key values. So just do that for every key so that the jump will be more smoother. Here try to make a reverse U-curve where the peak value should be touching around 1 like this. So now the jump will be lot smoother. So when you're done making this curve, here select this option so that the timeline will end as soon as we reach the last key. Alright, so from here we are going to receive a jump timeline value. And this update pin is going to fire every frame until the timeline finishes. So every frame, we are going to move this capsule using the timeline value to make our character jump. So here get the capsule component, and from this search for add relative location. Now here just right click and split the structure to get each axis separately because we just want to change the value of Z axis that affects the vertical movement. Now here we are not just going to directly use the jump value in the Z axis. First of all, we will be getting the timeline value gaps in each frame. For example, first the value is at 0.09, then the next frame it is 0.1, and then its next frame the value is 0.11. That means each second the gap is 0.01. So this is the value that we need, and onto this we are going to multiply a jump height value so that the multiplied value will be affected by this timeline curve. So firstly, to get those timeline gap values, first we need to store the previous timeline value. So let's name this previous jump timeline value, and we are going to store this value just after the character has moved. So a better and organized way to do this is by using sequence. So hold S key and just click. So we will get this sequence. So firstly the character will move, and just after that we are going to store that timeline value. So now the next frame, when this update pin will fire, we will already have the previous timeline value stored. So what we are going to do is, we are going to subtract the current timeline value with the previous timeline value. And this will give us the gap between values in each frame. And on this, we are going to multiply the jump height value. So here let's right click and promote this to a variable, and let's call this jump height and plug this multiplied value to the z-axis. Now compile. So our default jump height is going to be 150. You can always experiment with this value, but 150 is going to be enough height for our character to jump. Now while our character will be jumping, the gravity is still on. So we need to turn it off while we are jumping. So right here, just set the gravity and make sure it's set to false so that the gravity will be turned off and it won't pull the character downwards. And also when the timeline will be finished, then we are going to turn the gravity back on. Now also, before we start our jump timeline, we have to make sure that the previous jump timeline is set to 0. Otherwise, it will give us the wrong value after every new jump. So before the timeline start, here make some space and just set the previous jump timeline value to 0. And before we test this, just make sure the gravity is enabled by default. Now let's play. Oh, okay, so inputs are not working. And that is because we haven't told our player controller that we are using this input mapping context. So we need to set this input mapping context so that we can use the inputs that we have assigned for the keys. And before that, first we are going to create our own player controller instead of using the default one. So from the world settings under the game mode, so here we are using this default player controller. So to make our own, just click on the add button and I'm going to save this player controller under the frameworks folder. Let's name this Doodle player controller. So inside our player controller, let's come to event graph. And here on the begin play, we are going to assign our input mapping context. So for that, first let's search for get enhance input local subsystem. And through this, search for add mapping context. And here select the IMC default because that is where we have all of our input setup. And here in the world settings, here just make sure you are using the player controller that we just created. And now let's play and test this. So we are still not able to control our player. And that is happening because in the game mode on begin play, here we are setting the input mode to UI only. That's why we are not able to control our inputs. So here when we start the game, that's when we are going to set the input mode back to game only. And just to keep it organized, I'm using sequence. So here get player controller and from this search for set input mode game only. And also search for set show mouse cursor and make sure it is set to false so that the mouse cursor will be hidden while we are playing. And now if we play, you'll see now our character can jump. And also we can move slightly left and right, but the left-right movement is quite slow, so we need to fix that. Otherwise the inputs are working perfectly fine. So to improve the movement of our character, just come to your character blueprint and in the character movement component, we need to tweak some settings. So first of all, let's search for constraint and here check this constraint to plane option. So with this option, now we can lock our character movement in a particular axis. So we want to lock its movement in the y-axis. So set the y-axis value to 1 and now the player won't be able to move in the y-axis since it's a 2D game. Now let's scroll down a little bit and here you find max walk speed. So it is going to be the movement speed of your character. I'm going to set this to 525. You can set this according to your game. And down here is the jump z velocity, which is the jump height of the character. The value doesn't matter here since we have used our own jump system. Now this air control is the most important value here because this controls how your character moves while he is jumping. So more the value, better the air controller you are going to get. So you can always experiment with these values, but I'm going with 1.4 since it works best for me. Now I am going to set air control, boost multiplier and velocity both to 0. You can always change them according to your game. Now this falling lateral friction is also an important value. So more the value, more friction it's going to have in the air. That means faster your character is going to stop in the left and right movement. So I'm going to set it to 2. Works great for me. And that's pretty much it for the character movement. So now if you play, now you'll see your character movement is a lot better than before, just like we want for a jumper platformer game. And one last thing we need to do for our character movement is that we have to flip the character in the direction where it is moving. So it is quite easier than you think. All you need to do is that you just have to change the scaling value of your sprite. Like here we have the scale value of 0.25. Now we just have to make the value negative. So this way the character sprite is just going to flip to the other side. So that's what we are going to do in the event graph. So here let's create a custom event and let's name this update character rotation. Now in this, first let's get the sprite component, and from this search for set relative scale 3D so that we can change its scaling value. And we want to keep the scaling value same in the y and z axis, so just get its relative scale value. Then just right click and split the structures and then connect y to y and z to z so the value remains same, and we will only change the x value since we want to flip character horizontally. Now first we need to know in which direction our character is moving. So for that, here get the character movement component, and from this search for get velocity. Then let's break the velocity to access each axis separately, and here we just need to check the x-axis that if it is greater or equals to 0. And depending on this condition, we are going to set the x scale value to negative 0.25 or positive 0.25. So for that, here get the select operator and plug this to the x value. Based on if this condition is true or false, we can provide it different values. So if it is true, then the x scale value is going to be 0.25, which is the default value. But if our character velocity is smaller than 0, then we are going to give it negative 0.25. So that's how we are going to flip our character. And now we are going to call this event right here whenever our character moves. So here just call the update character rotation event. So now let's play and test this. And here as you can see, our character is facing in the same side where it is moving. So until now we are done with our basic character movements, and in the next part we are going to add platforms in our game. So as of now, if we play, you can see our character can do basic movements like jumping and going left and right. But now we need to add platforms so that our player can jump on them. So for that, here in your content browser, let's create a folder where we are going to keep all of our platform classes. Now here let's right click and let's create a blueprint class of actor type, and let's name this base platform BP. Now open this up. Now here we are going to add some components, and when we create child blueprint class of this base class, these components will automatically be inherited into its child class. So we do not have to add components for every different types of platform that we are going to have. Now here first of all let's add paper sprite component, which will be our platform sprite. And the second component we need is a box collision so that we can detect if our player has overlapped with the platform. Now scale this down a little bit. Okay, so now we need to create child blueprint class of this base platform BP. So for that, you can just right click on this base class and create child blueprint class of this. Now if you don't see the option right here, then the another way to create child blueprint class is you can right click, go to blueprint class, and from the all classes, just search for the blueprint class of which you want to make child blueprint. So here it is base platform BP. Here it is. So select this and let's name this normal platform BP, since this is the first type of platform we are going to have. Now as we open this up, here you can see we already have these components inherited from its parent class. So this way we do not have to add the same components for every platform blueprint class. Now here just select your normal platform sprite. Here it is. And now we need to adjust this box collision size according to our platform. Now just to know how big or small this platform is in comparison to the background, here let's drag this platform into the level, and you can see it is quite big. So we need to scale this down. So in the base platform BP, here let's set this platform component scaling to 0.1. So if we change anything from the parent class, the change will reflect to its child blueprint automatically, as you can see here. And now you can see the scaling is now good. Okay, so now we need to scale this box collision according to the size of your platform so that it covers your whole platform. Like this. So when the player will jump on this platform, it will overlap with this box collision and we will know the character is jumping on the platform. Now once you are done with this, then we are going to create a platform container class inside which there is going to be horizontal space with 5 different slots, and the platform can be assigned into any of the random slot. So this way if we add up multiple platform containers throughout the whole game world, then for each container the platform location is going to be random horizontally. So that is what we are going to do. So for that, here first of all we are going to create a blueprint class of actor type, and let's name this platform container BP. Open this up. Now here let's add arrow component which represents the direction and the location of the slot. So just rotate it in the y-axis, which is going to be the forward direction. And now we need to add 5 of these arrows and assign them different location horizontally. So let's duplicate this. Now we are going to keep 100 units of gap between each slot. So starting from -200 in the x-axis, then place the second arrow at -100, then let's add third arrow which is going to be at 0, then the fourth one is going to be at 100, and the last one is going to be at 200. So all these slots are going to be at even gap. And now let's add a child actor component, which will be our platform blueprint. So from here, search for normal platform BP, here it is, and this platform is going to be our default platform for this component. Now all we need to do is to assign this platform a random location from these arrows. So to do that, here come to your construct script, and here get the platform component and search for set relative location. Since we are going to change its location in the x-axis, so split the structure to access each axis separately, and we just need to change the x-axis of the platform. And we are going to change it based on the random arrow component we will get and use its x location value to set the platform location horizontally. So to get the random arrow component out of all of these, first of all search for get components by class. And here search for arrow components, and this is going to give us all the arrow components that we have in this class. So from this, search for random array item. So it is going to give us the random item from the array. So this way we will get a random arrow component, and whichever the arrow component we get, we are going to get its world location, and that location we are going to use to set our platform location. So here we can recombine the structure pin, since still it's going to work the same. Now here, every time I compile this blueprint class, the platform location is going to be changed to any of the random arrow component location, as you can see here. And now we are going to add this platform container inside our background BP. So just go into your background BP. And here first of all, we are going to add a scene component inside which we are going to add all the platform containers that we are going to have in the level, so that all the platforms will stay under a scene component, and this way it will be a lot easier to manage all the platforms in the future. So here let's add a scene component, and I'm going to name this world root, and inside this we are going to add a child actor component. Let's name this platform container, and from the actor class, here search for platform container BB. Here it is. So this is going to be the bottommost platform container. So let's shift this somewhere at the bottom, like this. Okay, so here we are having some little issue with the platform location, and that must be because we did something wrong in platform container BP. Okay, so we are using the world location, but instead we need to use relative location of the component. Okay, so now the issue has been resolved, as you can see, and now let's play and test this. So here, as you can see already, we have our platform in the level, but nothing is happening when we collide with it. So now we need to add jump whenever our player will collide with the platforms. So for that, here come to your normal platform BP, and here we have this box collision. So when the player will overlap with this box, we want a player to jump. So for that, here right click on the box collision component, and from the add events, add a begin overlap event. So now when any object will overlap with this box, this event is going to trigger, and we wanna ensure that the object that overlap with this box is a character, not just any other object. So for that, let's go to your character blueprint. And here from the details panel, let's search for tag, and here let's add a tag. Let's name this character. This tag will help us to identify this actor. So come back here, and now from here, search for actor has tag. Here it is. And here give it the same tag name that we used for a character, so that if the overlapped actor has this tag, that means it is our character, since our character only has this tag with this name. So when our character overlaps with this box, then what we are going to do is, then we are going to call this code, which is for jumping the character. But before we jump our character, we are also going to check some other things, like when the overlap happens, the character is falling downwards, and also if the player's feet location is even on the platform or not. So for that, we can create a separate custom event here, which we are going to call when we overlap with the platform box. But to communicate between this and our character blueprint, we are going to use blueprint interface, which is a better way to communicate between blueprints. So here, right click, and under the blueprints, let's create a blueprint interface, and let's name this character BP interface. Open this up, and here let's name this function normal platform overlaps. And now to make this blueprint interface work with our character, here just go to class settings and from the implemented interface, just search for character blueprint interface that we just created, now compiled. And now under the interface, here you can see all the functions of the blueprints. So just double click on this one and here you'll get this event just like any other custom event. And we are going to call this right here in the normal platform BP when we overlap with this box. So here just call the normal platform overlaps event and we don't need to provide it the direct reference of our character blueprint. We can just plug it to the actor reference and this will still work. Okay, so when our character overlaps with normal platform, then first thing we are going to check is if the character's velocity is in negative. That means the character is falling down and while falling down it overlaps with the box. Only then we will allow the character to jump. But if the character was already going up while it overlaps with the box, then we are not going to make the character jump, but only when it's falling down. So to check that, here get the capsule component and from this search for get linear velocity. So it will give us the velocity of the character when we overlap the box. So we can break this vector to separate all the axes because we just want to check z axis which has the values for the vertical movement. And if this value is smaller than 0, that means the vertical velocity of our character is in negative. That just means the character is falling. So if this condition is true, then we are going to execute all this code that is just going to jump our player. But since we are only running this code when we press any specific key, so here we are going to create a custom event for that. Let's name this jump character and plug it to this code. And now let's call this event right here when this condition is true. So now let's play and test this. And there you can see when our player lands on the platform, it jumps perfectly fine. But there is a small issue with this. Like here, if I show you the collision, just to show you what is the issue here, then here you'll notice even if the edge of the capsule overlaps with the platform, it will still make the player jump. But we only want to make the player jump when he lands on the platform. Means our character feet must be close to the platform. So that's what we are going to calculate now before we make our character jump. For that, go to the idle sprite of your character and here we are going to add a socket at the feet level of the character. So from here, add a socket and just drag it all the way to the bottom to the feet level of the character so that we can retrieve the world location of this socket and compare it with the platform location to check how close our character's feet is from the platform. Now here also make sure to name the socket to feet. Now we also need to add the socket in the jump sprite of the character. So just repeat the same procedure, drag the socket all the way down to the feet level and just give the socket the same name. So now let's come back to your character blueprint. And here before we jump, let's add a branch because we are going to check a condition here that our character's feet location should be near enough the platform location. And to check that condition, first we need to get the platform location here through this event. So just double click on the event to go into its blueprint interface and here we are going to add an input parameter to receive the platform location. Make sure the variable type is vector. Now go to normal platform BP because this is where you are calling this event and here you need to provide this parameter to platform location. So we are going to give this box component location. So just get its world location and plug it to the platform location parameter. And now in your character blueprint, here we will receive that value. So from this, let's break the vector since we are going to compare the z-axis and we are going to subtract this value. So now we need to get the feet location of the character. So here get the sprite component and from this get socket location. And here just provided the socket name which is feet and then break this vector and we are also going to use its z-axis to compare it with the platform z location. And after the subtraction, it is going to give us the distance between the character's feet and the platform location. So now we want to check if they are in a particular range. So for that, here search for in range float, where the minimum value can be -25 and the maximum will be 25. So if their distance is in this range, then the condition will be true and then the player can jump. Now here we can do one thing. Whatever the calculation we did here, just right click and collapse it into a function. And let's name this function is character feet on platform. And make sure to check this pure option so that it will remove the execution pin from the function. And this way the code remains clean. So now let's play and test this. And here you can see our player can jump on the platform and the capsule edge issue is also fixed. So as of now, we just have one platform in our level where we can jump on. And now we need to add more all the way to the top of the screen. So for that, let's go into your background BP. And here first we need to set the upper limit till where we can add the platforms and then the lower limit after which the platform will start to recycle to the top. So for that, we are going to use box collision. Let's name this one max box since it will be the max limit for the platforms. Now scale this according to the width of the background like this, and then place this all the way to the top of the background like this. So this is where the platform's limit will be, and then add another box collision and name this one min box since it is going to be the lower limit for the platforms, and place it all the way to the bottom. So when the platforms will come downwards and overlap with this box, those platforms are going to recycle all the way back to the top, and this will create an endless loop. But before we do that, first what we are going to do is, here we have the bottommost platform container, and from this we are going to have some random gap, and after that gap we are going to add one more platform container, and then again we are going to have some random gap and then add another platform container, and this process will keep on repeating until we fill up platforms till the max box. So yeah, that's what we are going to do for now. So first of all, we need to store the Z location of our max box and the min box, so that while filling up the platforms, we will already know the max height until which we can fill the platforms. So here come to construct script, and here first of all get min box, and from this get its relative location. Now here right click and split the structure since we only need to store the Z location of the min box. So just right click and promote this to a variable, and let's name this minimum platform height. Now we need to do the same. So here copy this and here use max box to get its relative location, and here promote the Z location to a variable, and we are going to name this maximum platform height. So for the max height, we are going to add some more value in it just to extend the max limit. So let's add 200 units more in the max height. So now the max limit is extended till here. We did that so when the platforms will come down, then we will not run out of the platforms since we have the extra space from the top. So now we need to store the current platform height, and the current platform height is going to be this one that we already have, because we are going to start from this platform to add some gap and add more platforms, and then we'll update the current platform height to the new one to add the new platform on top of that, and this will keep going on. So we need to store current platform height. For that, get this platform container, then get its relative location and promote its Z location to a variable, and let's name this current platform height. Now since I already told you that we are going to add many platform containers, and as these platforms will come downwards and comes to the minimum limit, then we need to recycle them all the way to the up, so that we can keep using the platforms and the game can become endless. So we are going to store all the platforms in an array. So here create a variable, let's name this platform containers, and from the variable type search for child actor component. We are using this variable type because these platform containers are child actor in this background BP. Now here just make sure to convert this variable into an array so that we can store multiple platform containers inside this variable. Now here the first platform container that we are going to add in this array is going to be this one that we already have. So for that, here get the platform container, and from this search for add. And here we are going to add this platform container that we already have. And the other platform containers we are going to keep adding in the runtime. But for now we are done with the initial setup, since now we have all the values that we need to fill up the platforms in the level. So now to actually fill the platforms in the level, come to event graph, and here let's create a custom event. Let's name this on game start. So we are going to call this event when we click on the start button, because that's when we are going to add the platforms. But instead of calling this event from the start menu or the game mode, we are going to call this event from our character blueprint, because there we also need the reference of this background baby, because we need that in the future. So just go to your character blueprint, open this up, and here let's add a event begin play, which is going to fire as soon as this character spawns in the level, and that happens as soon as we click on the start button. And that's when we are going to call that event that is in the background BP. So for that, here search for get actor of class, and from the classes select the background BP. So this will find background BP from the level, and here we will get its reference. So we are going to right click and promote this to a variable so that we can store the reference of the background BP. And now from this reference we can call that on game start event. So now when we call this on game start event, then what we are going to do is we are going to start adding the platforms from the current platform height to all the way up to until we reach the max platform height. So for that, here get the current platform height and check if it is smaller than the max platform height. And until this condition is true, then we are going to run a while loop. So this loop will keep on running until this condition gets false. So every time this loop fires, then what we are going to do is from the current platform, we are going to add a random height gap, and this new height is going to be the new current platform height, and that is where we are going to add a new platform container. So here to get the random height value, here search for random integer in range. Now here we need to provide it the range to get the random integer value. So let's promote this minimum value to a variable, and this is going to be our minimum gap value. The same way, promote this max to a variable, and this is going to be our max gap. Now for the initial difficulty level, the minimum gap value is going to be 1 and the maximum gap value is going to be 2. So these values are for the first difficulty level, and as the difficulty level will keep on increasing, these gaps value are also going to increase, which will eventually make the game more harder. So here let's multiply this value with 25. So how this will work is, this is going to give us the random value between minimum and maximum. So if we get the minimum value, which is 1, so after the multiplication, the gap will be 25 units. And if we get the random integer 2, then after the multiplication, the gap will be 50 units. So whatever the random gap value we get, we are going to add it to the current platform height. So here let's add this value with the current platform height. And this is going to be our new current platform height. So once we get the new height value, so that is where we are going to add the new platform. So here search for add child actor component. So it is going to add a child actor component in this blueprint class, just like this that we have. And from the details, here just make sure to select platform container blueprint class, since this is the blueprint class that we actually want to add to have the platform. Now from the relative transform, search for make transform. And here we just want to change the Z location of the platform. So just right click and split the structure. Now here we are going to set the platform Z location to this current platform height. So here get the current platform height and plug it to the Z location of the newly added platform. Now once we added the platform, then we are going to attach it to the world root so that it will be a lot easier to manage all the platforms in the future. So here get the world root component, and from this search for attach component to component. Now here make sure this world root component is the parent and this added child component is plugged to the target so that it remains under the world root. And then we are going to add this platform inside this array. So just search for add, and here just add this newly added child actor component into this array. So now let's play and let's see if it really generates platforms all the way to the top. So here let's play, and here you can see it has generated the platforms with the random gap all the way to the top of the screen. Like here, if I eject from the player, there you can see the platforms are filled all the way up to the max platform height that we have set before. So yeah, it is working, and in the next video, we are going to bring the platform downwards instead of jumping the player after a certain height so that the player will always remain in the screen. Alright, so now what we are going to do is, so when our character will reach at the center point, after that when the player will jump, instead of changing the player's location, we are going to change the position of all the platforms and bring them downwards. So this will give us the illusion of player going upward, but instead the platforms are the one, those are coming downwards. Now first of all, we are going to add a box collision here, and let's name this center box, since this box will let us know if the player is at the center. Then scale this up like this, and we are going to place it in such a way that it will overlap with the player when we reach it at the center point. So here, as soon as the player reaches the center point, then it will overlap this center box. So now right click on the box, and from here add a on component begin overlap event. Now here first of all we want to ensure that the overlapped actor is our player. So for that we are going to check if the actor has a tag with name of character. So if it is true, that means it's our player which overlap with this box. And after this, we have to let the player know that if it is at the center or not. So for that, here let's create a boolean variable. Let's name this character at center. So if the character is at the center, then we are going to set its value to true, otherwise it is going to be false. Now to change this boolean value, we need to have some communication between these two blueprints. So for that, we are going to use blueprint interface. So let's go to your character blueprint interface, and here let's add a function. Let's name this move platform down. And here add an input parameter. Let's name this at center. Now this parameter value is going to tell us if the character is at the center or not. And now we need to define this function inside our character blueprint. So here in your character blueprint, search for event move platform down. And inside this event, we are going to set the value of character at center boolean. So it will receive the value from this parameter, which we are going to set to true when our character overlap with the center box. So here just call the move platform down event and set this parameter value to true. And here the target is going to be the overlapped actor. Now if the character falls down and gets out of the center box, then we are going to change this value to false. So for that, right click on the box component. Here add an AND overlap event, and here just copy these same nodes. And here before we change the boolean value, first we are going to check a condition. And that condition is that only if the character gets out from the center box from the bottom, only then we are going to change the value. Because if the character leaves the center box from the top, then it is still above the center position. And we don't need to change the value in this condition. So to avoid such glitches, we are going to check if the player leave the box from the bottom. Only then we are going to set the value to false. So here from the other actor, get actor location, so that we will get the character's location, and make sure to split the structure. And we are going to subtract the Z location of the character with the Z location of this background BP. So here get actor location, right click and split the structure and subtract it with the character's Z location. And we are going to check if the subtracted value is less than 0, but let's set it to 100 since it's slightly above the center point. And now plug this to the condition, and we are just checking this condition so that we can avoid the bugs. And now here make sure to set this parameter value to false so that it will change this boolean value to false if the character drops below the center point. Now down here in the jump system, we are going to make some changes. So since we use this timeline value to make the player jump, then we are going to use the same timeline value to bring all the platforms downwards once the player reaches at the center point. And we are going to do that just by checking a condition here, that if the character is at center or not. So if the character is not at the center yet, then we can just simply jump. But once the character reaches at the center point, then what we are going to do is, we are going to move this world root component downwards instead of the player jumping upward. And since all the platforms are under the world root, then all the components will move along with the world root. So here to access that world root component, get the background BP reference, and from this you can search for world root. And we are going to do the same thing with the world root that we do with the capsule component to jump the character, except we are going to multiply this jumping value with -1 because the platforms have to go downwards, and plug this to the Z value. Now before we move the platform downwards, we are going to check one more condition here, that we are only going to move the platform downwards only if the timeline value is going up. Otherwise, if the timeline value is coming downwards, that represents that the player is now falling, so we don't want to change the platform location while the character is falling, but only when the character is jumping. So here to check if the timeline value is going up, what we are going to do is, here just copy these nodes from here, where we are going to subtract the current timeline value with the previous timeline value, and we are going to check if it is greater than 0. So if this condition is true, then we can move the platforms downwards. Now how does this condition works? So here let's suppose the previous timeline value was 0.19 and the current timeline value is 0.21. So if we subtract the current with the previous one, then we will always get the value greater than 0. So this will show the timeline value is increasing. But if the timeline value is not increasing, then we can just move the player instead. So now let's play and test this. So as the player reaches the center point, then the platform starts to go downwards, and it gives the illusion like the player is the one that is going upward. So if I eject from the viewport, there you can see all the platforms are now below. Now we have to make a platform recycle system so that the game will become endless, but that's for the another part. For right now, what I want you to focus on is here. If you notice here, once the player jumps, then the player sprite never changes back to the idle sprite, and we need to fix that. So what we want is, once the player starts to fall, then we are going to change its sprite back to the idle sprite. So here, if you go into the timeline, here the time of 0.75 is going to be the exact time after which the character is going to fall rapidly. So that's when we are going to change it to the idle sprite. So here, with the start of this timeline, we are going to start a timer of 0.75 seconds. For that, here I am adding a sequence. So first it will start the timeline, and just after that we are going to start a timer. So for that, set timer by event, and here set the timer of 0.75 seconds, since that is the exact time after which we want to change to idle sprite. And from this event, let's create a delegate and let's name this reset flipbook. So this event will fire after 0.75 seconds. And now get this sprite component, and from this set flipbook. And here just select your character's idle flipbook. So this will change your character's sprite. And here just make sure to promote this timer to a variable. Let's name this jump timer. And we have to make sure to clear the timer before we start it, just to avoid the bugs. So just plug it somewhere before the starting of the timeline. And now let's play and test this. And here you can see, as the player starts to fall down, the character sprite switch back to the idle, and now it's looking a lot better. So as of now, as our player keeps going up, then soon it will come to the end and there will be no further platform after a certain point. So now we need to recycle the platforms, those goes out of the view below the screen. So first of all, let's go to your background BP, and here we have this min box that we added in the previous part. So this is the lower limit for the platforms. So when the platform comes down and hit this min box, at this point of time, the platform is out of the screen. So we are going to recycle it back to the top so that we can reuse the platform once again. And for that, we are going to use this current platform height value, which will be the height of the topmost platform. And on that, we are going to add a random gap, and that's where we are going to set the location of the recycled platform. So for that, let's go to event graph, and here let's create a custom event. Let's name this start recycling platform. So when we call this event, that's when we are going to start recycling the platforms. And we are going to call this event right here when this loop completes. So this was the loop of generating platforms all the way to the top. So after all the platforms are generated, that's when we are going to start recycling the platforms. Those goes below the screen. So on loop completed, just call start platform recycling event. So to recycle the platforms, here first of all, search for set timer by event. So here let's set the timer to 0.1 and check this looping option. And from this event, let's create the delegate and let's name this recycle platform. So basically, this is a timer that is going to call this event again and again after every 0.1 seconds in a loop. So to recycle the platform, for every 0.1 seconds, we are going to check if the platform is at the bottom of the screen at this location. So this height location we have saved inside this minimum platform height variable, which is the z location of the min box. So we can use this variable to check if it is smaller than this value. Now here first we need the reference of the bottommost platform so that we can compare its location. So all the platforms that we have in the level is stored in this array. Since on the game start, when we generate all the platforms till the top, we keeps on adding platform one by one into this array. So here using this platform containers array, we can access every platform. So here get a copy. And here from the index, just right click and promote this to a variable, and let's name this current platform index. Compile and make sure its default value is 0, since the 0 index is going to give us the first element from this array, and the first item is going to be the bottommost platform. So we need to check its location since it is the one which is going to go below the screen first. So here get its world location and then right click and split the structure since we only need to compare the z location. So here check if it is smaller than minimum platform height. So we are going to check this condition for every 0.1 seconds. So once the platform is below this minimum box, that means it's out of the screen, and now we need to recycle it back to the top. And to do that, we can use this current platform height. This current platform height is the height of the topmost platform. Like here on the game start, when we generate the platforms, we store the platform height into this variable one by one, and each time we add a new platform, here we give it a random gap. So the same thing we are going to do to recycle the platform. That on the topmost platform, we are going to add a random gap, and that's where we are going to set the position of that recycled platform. So here just copy all these nodes and paste it here to do the same thing. So once we get the height location for the recycled platform, so here we can just set relative location, and here just split the structure and plug this height value to the z-axis, and now it will change its location from bottom to the top. So once the platform changes the position to the top, now the bottommost platform is going to change to the next platform from the array. So here we need to change the index value, and we are going to add the index value by 1 to access the next element of the array. So here after we change the location of the platform, then here get the current platform index, and we are going to add it by 1 so that we can access the next platform from the array. But there is a problem with this. Since this index value is going to keep adding, but this platform container array has the limited items. So the index is going to exceed the limit of the amount of items that we have in the array. For example, in this array we have 3 platforms, so after every recycle, index increases by 1, and once it reaches the last element, then we want to go back to the 0 index, so that it will keep looping the items in the array. So to do this, there is a mathematical method that we can use before we add the current platform index. So here if you take any smaller number and mod it with a greater number, then it is going to return the smaller number itself. So here if we mod 1 with 3, then we will get 1 since it's a smaller value. If we 2 mod 3, it is going to return 2 since it's a smaller number. But if we mod the same number, then it is going to return 0. So this mathematical technique we are going to use to keep looping the index value in the array. So here before we add 1 in the current platform index, we are going to mod the index value with the last index of the array. So for that, first we need to get the last index value of this array. And to store the last index value, here let's create a variable and let's name this last platform index, and here set the variable type to integer. Now we are going to set its value right here before we call this platform recycling event. So to get the last index value, here first get the platform container array, and from this we are going to get its length, which is the number of items this array has, and we are going to subtract 1 from this value since the index value starts from 0. And it is going to be our last platform index value of this array. So now in the platform recycle event, here get the last platform index, and now we are going to do the modulus of the current platform index with the last platform index. So now we are going to check after the modulus if the value is same as the current platform index. In that case, we are just going to simply add 1 into the current platform index. But after the modulus, if the value is 0, in that case, we are going to set the value of current platform index to 0. So here check if this modulus value is equals to the current platform index, and based on this condition, its value is going to differ. So for that, we are going to use select operator, where we can provide different values based on if the condition is true or false. So if the value remains same after the modulus, then we are just going to simply add 1 into the current platform index. But if the condition is false, then we are going to set the current platform index to 0. So this way we can reset the index value back to the starting to keep looping in the array. Alright, so now let's play and test this. Okay, so one thing to notice here is this default platform stays visible even before starting the game. So we are going to hide it before we start the game. But for now, let's start the game and let's see if the platform recycle system is working fine or not. So here let's keep jumping on the platforms and let's see if the platform really recycles and makes the game endless. And there you can see the platform recycle system is working perfectly fine, and now the game has become endless. Alright, so now we need to hide this platform container before we start the game. So select it, and from the details panel, search for hidden in game and make sure to check this option. So it is going to hide this platform container by default, and we are going to make it visible again right after we call this platform recycling event. So here get the platform container, and here search for set hidden in game and make sure to keep this value to false so that this platform container won't be hidden in the game anymore. Also, there is one more thing that we are going to do. For that, go to your character blueprint, and here on the event begin play, we are going to call this jump character event, so that as soon as our player spawns, it will take an initial jump so that the player will not just fall immediately. So now if we play, there is no platform before we start the game, and as soon as we start, the player takes the initial jump and the platforms will just keep recycling, and we can just keep on playing this game and we will never run out of the platforms. But as of now, there is only one type of platform in this whole game, so now we need to add more different types of platforms. So now we are going to add more platforms in this game. For that, in your content browser, just go where your platform blueprints are. And here we are going to duplicate this normal platform BP, and let's name this breakable platform BP. Open this up. Now here the first thing we are going to do, we are going to change this normal platform sprite to breakable platform sprite. Now, when the character overlaps with the platform box, we are not going to call this normal platform overlap event, since this event leads our player to jump. But when the player overlaps with this breakable platform, we are just going to change the sprite to this broken platform sprite, and the player will just fall down without any jump or anything. So here instead we are going to call a different event. So for that, in your character blueprint interface, just duplicate this normal platform overlap function, and let's name this breakable platform overlaps. And here we are going to add one more input parameter, which is going to be a paper sprite component, since we need to pass on the reference of the platform sprite component to our character blueprint so that we can change its sprite there. So now here, instead of this, call breakable platform overlap event. And here give it the platform location, and for the platform sprite, here just give it the reference of this platform sprite component, and this event target is going to be this other actor. So now we are going to define this event logic in our character blueprint. So in your character blueprint, here from the previous episode, we defined the logic of normal platform overlap, where we first check if the character's velocity is in negative, that means the player is falling down, and then if the character's feet is on the platform, only then we are going to jump our character. So the similar way, we are going to define the breakable platform event. So here search for event breakable platform overlap. Now here just copy all these nodes except the jump character event, and just make sure to connect the parameter. So when our player lands on the breakable platform, then through this platform sprite reference, we are going to change this sprite to the broken platform sprite. So before that, from this platform sprite, here get sprite, and we are going to check if our current sprite is not already equals to the broken platform sprite. Only then we are going to change the sprite, otherwise it means the platform is already broken. So you can pick the broken platform sprite from the content browser and select it here to check if it is already not this. If it is true, that means the platform is not broken yet, and that's when we are going to set sprite to the broken platform. Okay, so now we are going to add one more logic in this overlap event, that in the previous part, we made this character at center boolean, where if it is true, then the platforms moves down, and if it is false, then the character moves up. So when the character is at center, then the platforms are moving up. So this condition will get false since the character is not the one which is falling down. So we need to make an exception here, that when the character at center is not true, only then we are going to check if the character is falling. Otherwise, we can bypass this condition. Now the same thing we need to do for the breakable overlap event. So just copy this condition, and on false, just bypass this falling condition. We did this so that we can avoid any possible bugs. And now we are basically done with setting up the breakable platform, and now we need to make a moving platform. For that, here let's duplicate the normal platform BP, and let's rename this to moving platform BP. Open this up. Now here we are going to keep this overlapping event the same, because we want that when our player lands on this moving platform, then the player should jump. Now the only thing we are going to change here is this sprite, so just change it to the moving platform sprite. Okay, so now we have three types of platforms in our game: normal, breakable, and moving platform. But this normal platform is the only one that spawns in the level, and now we need to spawn these other platforms too. So before we do that, first right click, and here let's add an enum. Let's name this platforms type enum. Open this up. And here we are going to add three enumerators since we have three types of platforms. So the first one is normal platform, second is breakable platform, and the third one is moving platform. Now let's save it. So now we are going to add this enum as a variable in our background BP so that we can pick any one of these platforms and add it in the level. So in the background BP, here let's add a variable. Let's name this platform type, and from the variable type, search for platform type enum that we just made. Here it is. Now the whole purpose of making this platform type enum was that every time we recycle a platform, then before we set its position back to the top, first we are going to pick what type of platform we want to change it to. For this video, we are going to pick any one of the random platform just for the demonstration and understanding. But in the next video, we are going to pick platform type according to the difficulty level and the probability system. So here, before we change the location of the platform, first we are going to set the platform type. And we are going to pick any one of these platforms randomly. So for that, here let's get random integer in range, where the minimum random value can be 0 and the maximum can be 2. So there are 3 possible values we can get randomly. Now let's convert this integer value to byte so that we can plug it to the platform type enum. So it is going to pick up the enum value according to the index. Now here you can also right click and collapse this to a function. Let's name this getNextPlatform since that's what it's doing here, and make sure to make this function a pure function so that it will be more clean. So you can double click on the function to get inside it, and here you'll see we have the same thing here. Now in the next part, we are going to do a lot of things inside this function to get the platform type based on the difficulty level and the possibility system. But for now, let's just keep it like this so that we can see at least if this system is working or not. Now once we get the platform type and set its location back to the top, then we are going to set the platform class based on what type of platform we have got from here. So that logic we are going to set up inside the platform container BP since that is where the platform is. So let's go to platform container BP, and besides of changing the platform class, we are also going to change the horizontal placement of the platform so that we will get random location of the platform each time. So to do that, here we need to make a custom event inside which we are going to make this logic and call that event in the background BP. But again, we are going to use blueprint interface since it's a more optimized way to communicate between blueprints. So in your content browser, here let's create a blueprint interface for our platform container BP. Let's open it up, and here let's name this function update platform at random location. And here let's add an input parameter, and from the variable type, search for platform type enum, since this enum value is what we are going to pass on through this event. Now to define this function inside the platform container BP, here go to class settings, and here from the implemented interface, just search for your blueprint interface that you just made. Now compile, and now under the interfaces, here you'll find that function. And now you can define this event just like any other custom event. But first we are going to call this event here in your background BP after we recycle the platform. So here, just to keep things organized, let's add a sequence where on the second pin, here we will be updating the index value, and before that, we are going to call that event right here. And here we need to provide it the platform type that we have got. So here get the platform type variable and plug it to the parameter. And for the target, here we are going to use this platform container reference that we have currently recycled, so just plug it to the target. And now in the platform container BP, here first of all, we are going to set random location for the platforms horizontally. And for that, we already have the logic right here in the construct script that we have made in the previous part. So just copy these nodes and paste them right here. But before we assign them the random horizontal location, before that we are going to change the platform class. So as we have this child actor component here, where the default class is the normal platform BP. So we will be setting it to either breakable, moving, or the normal platform, depending on what type of platform we have got. So right here, get this platform component, and from this search for set child actor class. Now first of all, we are going to keep the class empty so that it will remove the previous blueprint class that it had. And after this, we are going to set the child actor class to whatever the platform type we have got from this parameter value. So from this enum parameter, search for select, here it is, and plug the return value to in class. So now based on this parameter value, we can provide a different blueprint class. So if the platform type is normal platform, then we are going to set normal platform BP as the new child actor class. If it is breakable platform, then we are going to set it to breakable BP. And if it is moving platform, then we are going to set it to moving platform BP. So after we change the platform type, then after that, we can change its horizontal location. Okay, so I did something wrong in the background BP. So here when we are calling this event, its reference is not going to be valid since here we are just giving it the reference of the component. But since it's a child actor component, so we need to access its child actor reference to have a proper reference to that blueprint class. So here get the child actor from the component and plug this instead to the target. So now let's play and test this. So here as you can see, after the initial platforms, we are starting to get the random platforms out of those three, and it's all endless. But currently they are all random, and in the next part we are going to unlock these platforms based on the difficulty levels, and also the gaps between these platforms are going to increase as the difficulty level also increases. So as of now we don't have any score system in this game, and we just keeps on jumping endlessly. So now to add a score system, first we are going to make a score UI. So for that, here let's right click and from the user interface, create a user widget. Let's name this score UI. Open this up. Now here first of all, let's add a text. So it is going to cover the whole viewport for just this small text. So what we can do is from here, select desired. So now it will only take the space that is required by this text. Now here let's set the text to score:00. Now here the 00 is going to be the score number and the score text is going to remain same. Now from here you can change the font size. I'm going to set it to 50, and also we are going to add an outline so that we can see the text clearly. So here from the outline, set the outline size to 1, and here if you zoom in slightly, you'll see there's a black outline around the text. And also let's set the justification to center so that the text will remain at the center. Now to change this number according to what score we have, for that we are going to create a functionality inside our graph. So here let's create a custom event. Let's name this update score and also add an input parameter from which we are going to receive the score value. Make sure the variable type is text. So now the value we get from this parameter, we are going to set it instead of this number on this text. So for that, first of all, let's rename this text. Let's name this score text, and here make sure to check this is variable option so that you can access this text reference inside your graph. So here get the score text, and from this search for set text so that we can change the text from here. Now whatever the score value we get from here, but first we want this score:text, and after that we are going to set the score value. So for that, from here search for format text. Here it is, and here just type what the default value of the text is, which is score:00. Now instead of this 00, use curly braces like this, and inside this just give it some name. So here it will give us the attribute value which we can plug to the score parameter so that it will put the score value in place of those curly braces. So now when we call this update score event with the score value, it is going to update this text. And now we need to display this score UI on the player screen. So for that, first of all we are going to create a game HUD UI that will be always on the player screen. And inside that HUD UI, we are going to add this score UI. So just right click and from the user interface, create a widget blueprint. Let's name this game HUD UI. Open this up, and here first of all, let's add a canvas panel. And since we are making this for mobile, so here select custom, where we are going to keep the width to 720 and height to 1280. So now the viewport size is similar to the mobile screen, and now we are going to add the score UI inside this HUD UI. And here make sure to check this size to content option so it fits perfectly fine, and also let's set the anchor to top left so that this score UI will always stay at the top left corner of the screen. And now we are going to create this game HUD UI through the game mode so that this UI remains throughout the whole level. So go to your game mode, and here on the event begin play we are going to create the game HUD UI. So here let's add a pin to the sequence. From this, create widget, and here just select your game HUD UI. Now from the return value, right click and promote this to a variable so that we can store the reference of the UI inside a variable, and then add it to the viewport. So now let's play and test this. So as you can see, we have the score UI here, but we only want to show it after we start the game. So for that, first of all let's come to your game HUD UI. And here from the details panel, search for visibility and set the visibility to hidden so that this game HUD UI will be hidden by default, and we are going to make it visible on the game start event. So here Add a pin in the sequence, and here get the game HUD UI reference, and from this search for set visibility. And here let's set the visibility to non-hit self only. That just means make the UI visible and non-clickable. And now you can see there is no game HUD UI until we start the game. And now we want to update the score value as our player keeps going up. So for that, if you go into your background BP, here since we know as our player keeps going up, these platforms will be moving down. And this world root component is the one which is responsible for moving all the platforms downwards. So what we are going to do is, we are going to use this world root's Z location value as the score value for our game. Because as much as the world root has moved down, that shows how much the character has moved up. So yeah, let's come back to your game mode. And here let's create a custom event. Let's name this start updating score. Now here, search for set timer by event. And let's set the time to 0.05 and enable the looping. And from the event, let's create a delegate and let's name this update score. So this timer will keep calling this event for every 0.05 seconds in a loop. And for every 0.05 seconds, we are going to keep updating the score value, which we are going to retrieve from the world root Z location value. And that score value we are also going to display through the score UI. Now first of all, here we need to get the world root Z location value, and for that first we need to get this world root component reference in a game mode. So for that, first we need reference of the background BP, which we have right here, and through this we can access the world root component. But there is even better way to get the background BP reference, and that is through the Doodle character reference. So if you go to your Doodle character blueprint, here you'll see on the begin play, we are already storing the background BP reference here. So in the game mode, as we have the reference of the Doodle character, from this we can access the background BP reference, and from inside it we can access the world root component. So yeah, it's an indirect way of accessing reference, but it's a lot better than storing the hard reference in every different class. Like here we are getting reference of background BP when we already have its reference in the Doodle character reference. So let's use it from there and it will save your game performance. So here since we got the world root component reference, so from this we can get its world location, right click and split the structure, and this Z location is going to be a score value. So just promote this to a variable and let's name the variable score. Now this value will be in the negative. Since the world root will be going down, so its Z location is going to be in negative, but we want the score value to be in positive. For that you can use absolute float. So this will convert the value into positive value. And now we can use this score variable to update the score text value here. So to do that, here get the game HUD UI reference. So through this game HUD UI reference, we can actually access this score UI. Just make sure to check this is variable option here, so that we can access the score UI reference. And through the score UI reference, we can call the update score event, which we just made some minutes ago. So here we need to provide it the score value. So just plug the score variable here, and here it will convert this float value to text. Now click on this drop down arrow, since here we are going to change some settings. So first of all, disable this use grouping option so that there will be no commas between the number values, and here set the minimum integral digits to 2. So even if the value goes 0, there will be at least 2 digits in that number. And also set the fractional digits to 0 since we don't want any decimal values in our score. And yeah, that is it. And now we need to call this start updating score event right here on game start. So now let's play and test this. So here, as you can see, as the player keeps going up, the score value also keeps increasing. So yeah, the score system is working fine, and now we want to increase the distance between these platforms as the score value keeps increasing using the difficulty system. Alright, so what we are going to do is, based on this score value, we are going to increase the difficulty level, and based on the difficulty level, we are going to increase the gaps between the platforms. So basically in the background BP, we have these minimum and maximum gap variables that handles the gaps between the platforms. So these variable values we are going to change depending on the difficulty level. So here come back to the game mode, and here let's add a variable and let's name this difficulty level up threshold. And just make sure it's a float. So this value is going to be the threshold value which the score needs to increase the difficulty level. So here let's compile, and here let's set the threshold value to be, let's say, 2500. So when the score reaches at the value of this threshold, which is 2500, then we are going to increase the difficulty level by 1. So here we need to check if the score value is greater than the threshold value. So if it is true, then we are going to increase the difficulty level. So for that, here let's create a variable to store the difficulty level of the game. Make sure it's an integer. Now here get the difficulty level and increment it if this condition is true. This just means increasing the value by 1. So after we increase the difficulty level by 1, then we are going to update the difficulty threshold value. Since the score has already reached to 2500, so now we need a new value for the score to reach in order to increase the difficulty level again. So to update the difficulty threshold value, here we are going to add 2500 value more into the threshold value. So for the second difficulty level, the threshold value will be 5000. And also one more thing I would like to do is here let's add one more pin, and here we are also going to add the half amount of the current difficulty threshold value. So divide it by 2 and add this on top of 2500. So this way the threshold amount will not just increase with the same amount every time, but will be more larger than the previous one. So every time the difficulty level increases, then we are going to increase the minimum and the maximum gap variable values that affects the gap between the platforms. So here we use these gaps values to get the random gap between the platforms. So these are just the range of gaps between the platforms, where the min gap is 1 and the max gap is 2, which we further multiply to have the actual gap, but these are the base values which controls the gap. So first of all, as the difficulty level increases, we are going to increase the max gap value all the way up to 5 one by one with each difficulty level. So the gap limit will extend all the way up to here, which will make the jump more harder. And after the max gap is set to 5, since the player cannot jump higher than that, then we are going to increase the minimum gap, which we are going to increase up to 3, and that will be the max difficulty level, where the minimum gap will be around 3 and the maximum gap will be around 5. So it will become a lot harder for a player to jump and land on the higher platforms. So now we need to access these variables in the game mode right here. For that, get the background BP reference from here, and from this you can search for set max gap, since this is the value that we are going to increase first. So here get the max gap value, and we are going to add 1 in this with each time the difficulty level increases. But we are going to do that until the max gap value is smaller than 6. That means the max gap value can increase up to 5. So when the max gap value reaches 5, then this condition will get false, and that's when it will be the time to increase the minimum gap. So now from the background BP, set the minimum gap variable, and we are going to add 1 into this minimum gap value with each difficulty level until its value is less than 4. That means the minimum value can go up to 3, and after that this condition will get false, and that's when we have reached the max difficulty level. So for that, here we are going to create a variable with the name of max difficulty. Make sure it's a boolean, and here we are going to set it on this false condition. The max difficulty variable is going to be true. So once we are at the max difficulty level, then we don't need to check this condition. So to save the performance, here we can just simply check if we are already at the max difficulty or not. So here get the not operator to check if we are not at the max difficulty level, only then we are going to execute all this code. And also here, as difficulty level increases, we are going to print a string which will be printing at what difficulty level we are at. So now let's play and check if this difficulty system works or not. So I'm just going to speed run here by pressing spacebar so that we can go up really fast to see how the gaps are affected as the score keeps increasing. So it prints 1, that means we are at difficulty level 2. Now we are at difficulty level 3, and you can already see the gaps between platforms have now increased from before. Now we are at 4, and the difficulty level will keep on increasing until 7, and you can already see as the difficulty level increases, the gaps between platforms also increases. That means it's working fine. Now as of now, if you notice, the moving platform isn't actually moving. It just remains still just like a normal platform. So now we have to make it move horizontally. So for that, come to your moving platform BP. And here we are going to create a custom event. Let's name this start moving platform. Now here let's add a timeline, and let's name this platform moving timeline. And we are going to play it from the start. Now double click on the timeline to go inside it, and here let's add a float track, since we will be needing the float value out of this timeline. Now here first of all, let's right click and create a key, and let's give it the time and value both 0. And then let's add another float key and let's give it the time of 2.5 and value of 1. Now here the moving platform will start from its default location, which is 0, and after 2.5 seconds later, gradually it will reach to its endpoint, which we represent using value 1. Now here let's add another float key and let's give it the time of 5 and value back to 0. So what will happen is the platform will start moving, and after reaching to the endpoint, it will move back to the start point, and this loop will keep on repeating itself. Now we are going to receive all that timeline value through this float value right here. And this value we will be using to move this default scene root component. Since it is the parent of all the components, so moving the default root component is going to move this platform and that box component. So here get the default root component, and from this search for set relative location. Here right click and split the structure, since we just want to change this X location value because we want to move the platform horizontally, which is being controlled by the X axis. So from this timeline float value, we are going to use lerp. Make sure to connect this float value to alpha. Now what does this lerp node do? So let's suppose this A value is 0 and this B value is 100. So here if the alpha value is at 0, then it is going to return whatever the value is there in the A, which is 0. Now if the alpha value is 1, then it is going to return whatever the value is in the B, which is 100. And if the alpha value is like somewhere in between like 0.5, then it is going to return the value between A and B, which will be 50. So this is how it interpolates between values. And here since the timeline value go from 0 to 1, then using this lerp, we can interpolate between A and B very smoothly. So plug this to the x-axis. Now here A will be the start location of the platform and B will be end location of the platform. And we will be receiving those values from this event parameter. So here let's add input parameter. So the first one is going to be start point. Make sure it's a float value. Now add another one and it is going to be the endpoint value. And also let's promote these parameter values to variables so that we already have the start point and end point values before we start moving the platform. So once we get the start point and the end point, then we can use them here to interpolate between them. So here plug the start point to the A and the end point to B so that it will be a smooth transition between the start point and the end point. Now we are going to call this event as soon as this moving platform is generated in the level. So that happens when we recycle the platforms, and after every recycle, here it chooses the platform and set its location back to the top. So if we go into this event, which is in the platform container, so this is where we recycle the platform. Now here we want to check if the platform type is going to be moving platform. That's when we are going to call that event that we just made. Now here let's get the branch. So if the platform type is not the moving platform, then we are just going to do the same thing that we were doing before. That was setting the platform random location horizontally, like it picks any one of the random arrow component and that's where it's going to set the platform location. But for the moving platform, we are not going to give the platform any random location. Instead, we are going to keep the platform location at the center horizontally because that's from where we are going to start moving the platform. So here we have the platform reference, and since we know it's a moving platform, then we can get its child actor since it was a child actor component reference. And from this child actor, we can cast it to moving platform BP. And through this cast, we can call start moving platform. So just call that event here. And now we need to provide it the start point and the end point for moving the platform. So the platform is going to start moving from the left corner where the first arrow is, and its X location is -200. And the endpoint is going to be this right corner, which location is 200 on the x-axis. So we can just directly put these values into these parameters, but there is a better way to do that. So for that, come to the construct script. So we can just retrieve these values from these arrow components. So here get the first arrow component, which is going to be the start point. So here get its world location. Right click and split the structure and promote this x-axis value to a variable, and this is going to be the start point. Now the same way, get this last arrow component, get its world location, promote the x-axis to a variable, and this is going to be the endpoint. So now since we have the start point and the end point, so we can plug these variables into the respective parameters of this event. So now this event will store these values into these variables and will interpolate between these values to move the platform from starting point to the end point. And now let's play and test this. So here you can see now these moving platforms are actually moving. But here you'll notice after the one rotation, these platforms just stop moving completely. So to fix that, in your moving platform BP, just go to your timeline. And here just make sure to check this loop option so that this timeline will just keep looping and the platforms will just never stop moving. But now if you notice, these platform types are very random and are generated very randomly. So what we are going to do is, now we are going to generate these platform types according to the difficulty level. Like for example, at difficulty level 2, the breakable platforms will start to generate. Then let's say at difficulty level 4, the moving platform will start to generate. And also we are going to control the generation ratio of these platform types. Like at the starting, the possibility of breakable platform will be around 10%, and as the difficulty level increases, this possibility will also increase for like 25%, something like that. So for that, let's go to game mode. And here first of all, we need to understand how many difficulty levels do we have. So if we do a little dry run here, then you will get it. Like each time the difficulty level increases, it checks this condition. Like here first of all, we checks if this max cap value plus 1 is less than 6 and its default value is 2. So this max cap value can be added up till 3 times before the condition gets false. So with each time, the difficulty level will be also added and will be at 3 until that condition gets false. So when this condition gets false, now it's time to add the min gap value until it is smaller than 4. So the default value of min gap is 1. That means we can add up this value 3 times. So the difficulty will be added up by 3 more levels, that is total 6 till now, and at the end when both of these conditions are false, then it is going to set this max difficulty boolean to true so that it won't run the further code after that. So till then we would have total 7 difficulty levels. So since now we know we have 7 different difficulty levels, so for each level we are going to assign different number of chances for every platform type. So for that, just go to your background BP. And here in the recycle event, this is where we decide what is going to be the next platform. So inside this function, here you can see currently we just pick any of the random platform, but now we are going to do that using the possibility system for each difficulty level. So let's delete these nodes from here. And now first of all, we are going to create a variable inside which we are going to store the possibility number out of 100 for generating that platform for each difficulty level. So from here, add local variables. So first of all, we are going to add possibility values for normal platforms. So let's name this n platform chances. Here set the variable type to integer and make this an array because we are going to store multiple values. So from here, add 7 elements into this array where we are going to store possibility values for each difficulty level. So for the first difficulty level, the possibility of having normal platform will be 100 since we don't want any other platform at the first difficulty level. Now in the second difficulty level, this possibility value drops down to 90, and then on third it drops to 80, then 70, 60, 55, and then at the max difficulty it will drop down to 50. Now the same way we are going to create one more array variable and it will be for the breakable platforms. So name this B platform chances. Now here just add 7 elements for each difficulty level. Now here for the first difficulty level, the normal platform has already occupied 100 possibility, so the breakable platform is left with 0 possibility. Now for the second difficulty level, normal platform occupies 90, so the breakable platform is left with 10. Now for the third level, it occupies 80, so the breakable is left with 20. Now the fourth level occupies 70, so here I can assign it rest of the 30, but I'm going to assign it 20 since rest of the 10 is going to be assigned to the moving platform because from the fourth difficulty level, we are going to introduce moving platform. So here just add the local variable which is an integer array and let's name this m platform chances. Here add 7 elements. Now here for the fourth level, the normal platform occupies 70, breakable occupies 20, so we are left with 10. And for all the previous level, the possibility is going to be 0. Now for the fifth level, normal platform occupies 60, so for breakable we are going to assign 25, and then for the movable we are left with 15. Then for the sixth level, normal occupies 55, so for the breakable we are going to assign 25, and for the moving platform we are going to assign 20. And then for the last difficulty level, the possibility of having normal platform will be 50 and the breakable platform will be 25. And then the moving platform is also going to have 25. So this is how I have set up my possibility system, but you can always change it according to your project. Okay, so now get the normal platform chances array, and from this get a copy. Now here, depending on this index value, it is going to give you that value. Like if the index value is 5, then it is going to give you the value which is at the index 5. That is 55 here, and that is the value that is going to give you. So on the index, we are going to give it the difficulty level number so that it will give us the correct possibility number for that platform according to current difficulty level. So for that, we need to get the difficulty level value here, which is on the game mode. So to get this value in the background BP without casting, for that we can use blueprint interface. So in the game mode blueprint interface, here let's add a function and let's name this get difficulty level, since that's what it's going to do. So here add a output parameter which is going to give us the current difficulty level and make sure the variable type is integer. So now if you go to your game mode and under the interfaces, here you'll find this get difficulty level function, and here you just need to return this difficulty level variable since that's value what we want. And now we can call this function in the background BP. So here call the get difficulty level function. So it is going to give us the difficulty level value. And for this function reference, we are going to get game mode and we are going to use this reference to call this function. And now we can just plug this difficulty level value into the index of this get operator so that it will give us the correct possibility number of generating normal platform. Now the same way, we also want the possibility number of the breakable platform and also of the moving platform. So do the same with all of them. Now once you get the possibility values of all the platforms, so now it's time to promote them to a local variable so that you can store their possibility values. So this one I'm gonna name normal platform chance. And just like this, I'm also going to store the possibility values of other platforms. So after you are done with that, then after this, we are going to get random integer in range, where the minimum value is going to be 0 and the maximum is going to be 100. So whatever the random value we get, we are going to promote this to a local variable and let's name this random integer. Okay, so now based on whatever the random value we have get here, based on that we are going to decide which platform we are going to generate. Like for example, if the difficulty level is 3 and we get the random integer of 85, then for the normal platform, it has gone beyond the possibility since that number is greater than 80. So now since the breakable platform has the rest of the possibility number, which will be from 80 to 100 and the random value was 85, so it is going to generate the breakable platform. Even though having breakable platform only had about 20% chance, but still we got the random value between 80 to 100. That's why breakable platform got the chance. Otherwise the majority chance was of the normal platform. So to build a system like that, first here let's get the sequence to keep the things organized. And from the second pin, here let's get a branch because here we are going to check if this random integer is in a specific range. So here get in range integer, where we are going to check if this random integer is between 0 to normal platform chance value, which is going to differ for each difficulty level. So basically if this random integer value is anywhere between this minimum value and this maximum value, then this branch is going to be true and that's when we are going to return this function. And here make sure to add an output parameter where the variable is going to be platform type enum, because through this function we are going to return what type of platform we are going to generate. So for this condition, if it gets true, then we are going to generate normal platform. Now if this condition gets false, that means that random value is beyond the possibility value of normal platform. So here let's add another branch after this condition gets false. Now here just copy this condition and here we are going to make some little changes. Now here the minimum range is going to be the normal platform chance value. That means let's suppose the difficulty level is 4. So the normal platform chance will be 70. So it is going to be the minimum value of this range and the maximum value is obviously going to be 100. But if we add normal platform chance with the breakable platform chance, then their addition will also be 100. Since if the normal platform value is taking 80, then rest of the 20 is taken by the breakable platform. And they both will add up to make 100. So if this random integer value is anywhere between these two values, in that case we are going to generate the breakable platform. So here return the enum value of breakable platform. Now the same way, copy this condition here. So even if this condition gets false, then we are going to check one more condition. Now the case where this condition can get false is when adding these values and using them as the max value is not actually equals to 100 because rest of the value is taken by the movable platform. So for example, at difficulty level 4, if the random value that we get is under 70, then we are going to generate the normal platform. But if the value is between 70 to 90, then we are going to generate breakable platform. And if the value is between 90 to 100, which have a very less chance, then we are going to generate movable platform. So here the minimum value is going to be this addition value. And for the maximum value, get the movable platform chance and add this value with the addition value of other two platforms, since all these platform values will be added up and will be equals to 100. So if this condition gets true, then we are going to return moving platform. So this is how we are going to assign the platform type that we want to generate next. And here make sure to plug this return value to this platform type variable. And now before we play and test this, here in the game mode, let's print this difficulty level every time it increases. So here I'm just going to speedrun so that we can quickly see the effect of difficulty level on how the platforms are generated. So as you can see already on difficulty level 1, these breakable platforms starts to generate and their generation rate is also going to increase as the difficulty level also increases. So now at difficulty level 4, you can see it now has started to generate moving platforms. So that means this probability system is also working to generate the platforms according to the difficulty level. Okay, so there are some issues with generating breakable platforms, and to show you what they are, here let me open up the paint to explain you the scenario. So let's suppose this is the normal platform and this is where the player lands, and the next platform here is the breakable platform, and after this there is one more breakable platform and then there is another platform. So here what the problem is, the player will first try to land on this platform and the player will fall obviously, and then after that the player will try to jump to the next platform and this platform will also break and the player will fall. So there is no way the player can ever reach to this platform so that he can jump any further. So to avoid this situation, all we have to do is we have to avoid generating breakable platforms 2 times in a row. If we do that, then we can avoid this situation. So to do that, here after we generate the new platform, then we are going to store the platform type that we have generated. So here just right click and promote this to a variable and let's name this previous platform, since that is what we are storing. So once we have the previous platform that we generated and the next time we recycle the platform, then we will also have the newly generated platform. So here we can compare the previous platform with the newly generated platform to check whether they both are the same. So here get the previous platform. Here check if it is equals to breakable platform. And then get this newly generated platform, and for this also check if it is equals to breakable platform. Now here I'm going to use AND operator to check whether both of these conditions are true. So only if both of these conditions are true, that means we have got 2 breakable platforms in a row. Now if this condition is false, then we are just going to do what we were doing before, that is generating the new platform. But in case we got 2 breakable platforms continuously, then we are going to simply generate the normal platform instead of the newly breakable platform that we have got here. And also we are going to store the previous platform, which is normal platform in this case. So yeah, it is going to avoid having 2 breakable platforms and replace it with the normal platform if we get one for the second time. Now there is one more issue after fixing this one. For that, let's go again to the paint. And here let's suppose this is the normal platform and our character lands here. And after this, let's say at the max height, we generate a breakable platform. And also coincidentally, again at the max height, it then generates another platform. Now here the issue is, if the player first tries to land on the breakable platform, obviously he's gonna fall, but also he cannot jump on the next platform either, since it is too high for the player's jump height. So to fix this issue, what we can do is, we can reduce the platform gap after the breakable platform and before the breakable platform. So let's say we reduce the platform gap by half, and we also do the same for the next time. So overall, now the player can reach to the next platform with the direct jump. So that's what we are going to do now. So here these are the nodes which controls the gaps between platforms and set the next platform height. So here what we are going to do is, first we are going to check if the current platform type and the previous platform type, if any one of them was breakable platform, then we are going to reduce the platform gap by half. So here get the platform type and check if it is equals to breakable platform. The same way, get the previous platform and check if it was breakable platform. Now here we are going to use OR operator, which is going to be true in case any one of them is true. So the reason behind we are using this is that this condition is going to be true for 2 times continuously, like before we generate the breakable platform and after we generated the breakable platform. Now what if this condition gets true? Now first of all, what we are doing here is, here we are doing this random calculation and that value we are adding to the current platform height, as you can see here. So here, if we divide this value by 1, then nothing is going to change, but we are going to divide it by 1.5 if this condition gets true. So that will reduce the gap between the platforms a bit. So here from this condition, search for select and plug this return value to divide. Okay, before that, right click and convert this pin to float and then plug it here so that we can have decimal values. Now if this condition is true, then we are going to divide the gap by 1.5. But if the condition is false, then we are going to divide it by 1, which will have no effect on the gap value. And this is going to solve the platform gap issue with the breakable platform. And now you can play this game endlessly without any issue. So in the next part, we are going to make the game over system where if our character falls down and goes below the screen, then the game is going to get over. So as of now, if our player falls down below the screen, then nothing really happens. So what we are going to do is, first let's go to your background BP, and here what we want is, when our player overlaps with this min box, that's when we'll know our player has fallen down the screen. So here for the min box, let's add our onComponent begin overlap event so that when any object overlaps with this box, then this event is going to fire. Now first of all, we are going to check if this overlapped actor has tag, and the tag name is character, since our doodle character have this tag. So if this condition gets true, that means the overlapped actor is our character. Now once our character overlaps with this min box, then we are going to disable the collision of this min box so that it cannot trigger again and again, and also then it will not cause any bugs. So here get the min box component, and from this search for set collision enabled, and here select no collision. Now after we disable its collision, then what we are going to do is, then we are going to move all the platforms all the way up so that it will seem like our character is falling, but instead the platforms are the one those are going up. So for that, here let's add a timeline. Let's name this fall timeline, and we are going to play it from start. Now double click to open this up, and here let's add a float track. Now here right click and add a float key, give it the time and value both 0. Now add another float key and give it the time and value both 1 so that it will be a linear timeline. And here make sure to check this use last key option so that the timeline will end when it reaches to the last key. Now to move the platform upward, we are going to use this float value from the timeline. And for that, we need to change the location of this world root component in the z-axis. So for that, get the world root component and here add relative location. Right click and split the structure since we only want to change the z value, and here let's multiply this timeline value by 100 and then plug this value to the z-axis. So now using this timeline value, it is going to move platforms up with a constant speed. So here let's play and test this. So as our player falls, you can see the platforms immediately goes up with a constant speed. But here's something to notice is, like as the player falls, the character suddenly disappears from the screen. But we actually want to show the character falling. So for that, what we are going to do is, as soon as the player hits the bottom, then we are going to bring the character slightly up and then it's going to go all the way down. Okay, so this player fall logic we are going to do inside the character blueprint. So just go to your character blueprint. And here we are going to create an event inside which we are going to define all that logic. So for that, let's go to your character blueprint interface. And here let's add a function and let's name this player fall. Okay, and now we can define this event inside our character blueprint. So here search for event player falls. And we are going to call this event right here as we overlap with the mini box. So here just call the player fall event, and for the target, we are going to use this other actor reference. Now before the player falls, we know the player must be jumping and this event must have been executed. And in this event, as we know, we set the player sprite to this jumping sprite. So when the player falls, we are going to set the player sprite back to idle. So here just copy those nodes and here select the idle flipbook. Now also when the player was jumping, we have started this timer to reset the sprite of the character. So here we also need to clear this timer so that it doesn't fire any event after the player has fell. So here get the jump timer and clear it. Now also on this jump timeline, we are using this previous jump timeline value to subtract it with the current one and use it to move the character, and we reset it before it starts the timeline. So that's also what we are going to do here. Just set its value back to 0, since here we are going to add a timeline for our player fall animation. So let's name this player fall timeline. And we are going to play this timeline from start. Now open this timeline and here let's add a float track. So here what we want is, when the player falls, we want the player to go slightly up and then all the way down. So for that, here let's add a float key, give it the time and value both 0. So this will be the player's current position. Now let's add another key and give it the time of 0.25 seconds and value of 0.8. Considering 1 as the target height, because from this point the player is going to float in the air for some seconds. So for that, here let's create another float key, give it the time of 0.75 seconds and give it the same value as previous one, which is 0.8. So for like half a second, the player is going to be at the same height as floating in the air, and after this the player is just going to fall down all the way below the screen. So for that, add one last float key, give it the time 1 and value -1. So this is going to be a dip in the height so that the player will just fall down immediately. And now to make this animation smoother, we are going to add curves in this timeline. So for that, you have to right click on the key and here select user. So this will allow you to adjust the curve of this key so that you can blend the values more smoothly. Now we are going to do that for all the keys we have in this timeline. Now here for this key, make sure to adjust its curve in such a way that its peak value touches the value of 1. Also slightly adjust it from here, like this. And also we want to make the falling of the player smoother, so you can also adjust the curve value from here so that it will blend the values properly. And also make sure to check this use last keyframe option so that the timeline will end with the last key. And we are going to access all this timeline value from here. And using this timeline value, we are going to move our player, just like we do right here when we make the player jump. So here just copy all these nodes that we use after the timeline to make the player jump and paste all these nodes right here just to make this process faster. And here we are going to subtract the current timeline value with the previous one and then multiply it. And here instead of using this variable, here we are just going to provide it some different value. So more the value, with more intensity, this timeline value will work. So here I'm going to give it value 250. You can always change it according to your game. Now after we change the position of the player, then after every location change, we also store the timeline value. So here just make sure to give it the current timeline value so that it can use it for the next time. And also we have disabled the gravity while the player is falling. So now let's play and test this. So as the player falls, there you can see now there is a smooth animation of player falling. Alright, so now what we want is, as soon as this timeline finishes, then we are going to show a game over UI to the players so that we can retry the game again. So to make the game over UI, here let's right click and from the user interface, create widget blueprint. Let's name this game over UI. Now let's open this up and here first of all let's add a canvas panel. Now since this is for the desktop by default, so we can change it from here. Just select custom and here set the width to 720 and height to 1280, and now the canvas is set up for the mobile screen. Now first of all we are going to add a text and here check this size to content option so that it covers the whole text, and let's set the text to game over. Also let's increase its size a bit, and since we want this text to remain at the center of the screen, for that we can set the anchor to center and place it accordingly. And also we are going to add outline to this text. So from the outline settings, set the outline size to 1. And also we are going to change its color to red, as you can see here. And also we want to show the score of the player inside this widget. So for that, we are going to include the score UI in this widget. So here search for score UI. So let's drag it to the center. And let's scale the box properly. Now for this also, let's set the anchor to the center. Now we also want to show the highest score of the player. For that, let's add a text. Bring it to the center. And let's name this highest score column and then the 00 number, which we are going to change according to the highest score value. And here make sure to set the justification at the center so that the text will remain at the center no matter how long the value is, as you can see here. And also you can set the size of the text according to your game. And also for this text, we are going to set the outline size to 1 and let's keep the outline color to black. And also make sure to set the anchor at the center like this. And now we want to add a retry button. So from here, let's add a button in this widget and I'm gonna place the button at the bottom and let's scale this button a little bit and let's set this button color to green like this. And then let's add a text into this button and name this retry. And also for this button, let's set the anchor to the bottom so that it stays at the bottom of the screen. So now when we click on this button, then we are going to restart the game. So for that, first of all check this is variable option so that you can add on click event from here. So when you click on this button, then we are going to execute a console command and that command is restart level so that it will restart the level as soon as you click on this retry button. Okay, so now as soon as this widget is displayed to the player, then we are going to set these scores values. Now this score value is we are going to set from inside score UI. And for that we already have this update score event. So that is what we are going to use to update the score. So here come to graph and here on the event construct, we are going to update those values since this event construct fires as soon as the widget is created. Now in order to access these score tags in the graph, make sure to select them and check this is variable option. And also you can rename these elements if you want. So now in the graph you can access these text. So first of all get score UI and from this we are just going to call that update score event. And here we just have to provide it the score text that we want to set. So here right click and promote this to a variable and let's name the score. Now set this variable to be instant editable and expose on spawn, so that we can set its value when we will create this widget. Now we also want to set the high score value. So here get the high score text and from this search for set text. And here we only want to change this number value to the highest score that we have. Rest of the text we want to keep the same. So just like we do in the score UI, like using this parenthesis to put the value here. So we are going to do the same for the high score. So let's copy this and paste it here. Now let's copy this high score text here and paste it over here. And since we only want to change this number value in this text, so in place of this, put curly braces and inside this, just name the parameter. So from here, we can give it the value that we want to put instead of the parameter. So for that, we are going to create a variable and let's name this high score and set the variable type to text and plug this variable on this value. Now set this variable to be instant editable and expose on spawn so that we can set its value as we create this widget. Now we are going to display this widget to the player as soon as this player fall timeline finishes. But we are going to do that through the game mode since it's a better place to create widgets. So first of all, let's go to game mode interface and here let's add a function and let's name this game over. And now we are going to call this event when this player fall timeline finishes. So here call the game over event and for the reference get game mode and plug it to the target. And now we are going to define this event in the game mode. So here search for event game over. Here it is. So when the player falls and the game gets over, then first of all we are going to remove the game HUD UI that we create over here and its reference is in this variable. So here get the game HUD UI reference and from this remove from parent. So it is going to remove the game HUD UI and after that we are going to create this game over UI. So here create widget and from here select the game over UI and here as you can see now it is asking for these score values because in the game over UI we set these variables to be instant editable and expose on spawn. So first we need to give it the score value of the current level which we have been storing right here in this variable and this value we are going to pass on to the game over UI. Now in this conversion node, we need to change some options right here to keep the score value simple and plain for the text, just like we do right here when we are constantly updating the score UI while playing the game. So just copy this conversion node and paste it right here since it already has all those options set up inside this. And as of for the highest score, we don't have any highest score stored yet since that's what we are going to do in the next part and we are going to receive the highest score from the save game. But for now, let's just keep it to 00. And after this, we are going to add this game over UI to the viewport. And then also we need to set the input mode to UI only. So for that, get player controller and search for set input mode UI only. And also from this, search for set show mouse cursor and make sure to set it to true so that you can see your mouse when the game is over and then interact with the button. Okay, so now let's play and test this. So here, as the player falls down and the game gets over, you can see it immediately creates a game over UI and it also shows the score value. And if we click on retry, you can see it restarts the level so we can start the game again and play the game. But here one thing you'll notice is that when the player falls, it still adds up the score and that score is shown up in the game over UI even if the player haven't gone up. So where is this score is coming from? So what happening is when the player falls down, this world root component goes up to move all the platforms up along with it. And since we are tracking the score value through this world root z-axis value, so that's why it adds up the score value when the player falls. So what we are going to do is, as our character overlaps with this mini box, that means the player has fell off and the game is going to get over. So at this point of time, what we are going to do is, in the game mode, here we have this update score event which runs a timer to keep updating the score value after every some seconds. So we are just going to stop this timer to keep updating the score value. So for that, here let's promote this timer to a variable and let's name this score timer. So now using this timer reference, we can stop this timer by calling this clear and invalidate node. And for that, I'm gonna create an event here, which we are going to call on overlap with the mini box. So to call that event in the background BP, for that we need to create that event using blueprint interface. So in the game mode blueprint interface, let's add a function and let's name this function stop updating score. And we are going to define this function inside our game mode. So here just search for event stop updating score. And now we just need to call this event right here after we overlap with the mini box. So here just make some space and to call that event, first let's get game mode. And through this reference, we are going to call that stop updating score event. Okay, so now let's play and test this. So now if the player fell down, then this game over UI is only going to show the score that has been recorded before the player has fell. Alright, so as of now, we can play the game and when the player falls, this game over UI appears on the player screen. But here the problem is, it doesn't store any highest score. So that's what we have to work on now. So for that, we need to create a save game class. And for that, in the content browser, let's create a separate folder, name this save game. And inside this, right click, click blueprint class. And from the all classes, search for save game. Here it is, select this. So we are going to call this Doodle Save Game. Now open this up. Now inside this class, we are going to add a variable that is going to store the highest score of the player. And make sure it's a float value. So in this save game class, we need to store all those values that we want to store locally on the player device. Just like the highest score value. Since even if the player closes the game, this value will be still stored in the player device. Now we need to load this save game class in order to set a new high score value or to get the current one. And we are going to make save game loading functionality inside game instance class. So first we need to make a game instance class. So for that, in your content browser, let's come to framework folder and here right click, create a blueprint class and from the all classes search for game instance. Here it is and let's name this Doodle Save Game Instance. Now the reason we made this game instance for loading save game class is because this game instance class is the first class that loads at the starting of the game and it stays valid for the entire game until the game is closed. So generally we load save game classes in the game instance since we can load the save game data from this class anytime we want. Okay, so now we need to tell this project that we are going to use this game instance. So for that, from under the edit, go to project settings and here in the maps and mode, from here select the game instance that we just created. So now we will be using this game instance. So open this up and inside this game instance, we will be defining the logic for loading this save game so that we can access this highest score variable after loading the save game. And here to make a load save game functionality, we are going to use blueprint interface with this game instance so that we can call that function anywhere without hard reference of the game instance. So first of all, we need to create blueprint interface for the game instance. So here let's right click and from the blueprints, create blueprint interface and let's name this game instance underscore interface. Now inside this, let's name this function load doodle save game. And here let's add an input parameter which is going to be the slot name and set the variable type to string. Now add output parameter since this function is going to give us the reference of doodle save game. So from the variable type, search for doodle save game. Here it is. And now to define this function inside the game instance, Here let's go to class settings and from the implemented interface, select the game instance interface. Here it is. So now under the interface, you'll find this function that we created there, and this is where we are going to make the functionality to load this Doodle save game. So for that, first of all, we are going to check, does save game exist? And for the slot name, we are going to provide this parameter value. Now here get the branch to check if the save game exists. So for the first time when we try to load the save game, then the save game doesn't exist already. So this condition is going to be false, and that's when we are going to create the save game object. And here select your Doodle save game, and this is what we are going to return. Since this is going to give us the hard reference of the Doodle save game, and we can access the highest score variable from this hard reference. So for the first time, the save game doesn't exist, so it creates one, and for the second time, it is going to get true. And now we just need to load save game from slot. And for the slot name, just give it the same parameter value that we gave here. And here if you notice, it gives us the generic save game object reference, but we need a hard reference of this Doodle save game class. So for that, from this reference, we are going to cast to our Doodle save game. And now we get the hard reference, and that is what we are going to return. So now we can use this function to load the save game and get the hard reference of the Doodle save game so that we can access this high score variable. Now where are we going to load this save game? So we are going to do that in the game mode. Right here, when the game gets over, then we create this game over UI, and this is where we need to give it the high score value so that we can set that value inside this widget right here, and this text value we set through this variable, and this variable value we set over here, and we are going to give it the high score value from this save game. And before that, we need to load the save game from the game instance. So here let's add a sequence to keep the things organized, and here first of all we are going to call that load Doodle save game event, and for the reference get game instance, and here you can give it any slot name, like I like to use slot 1, and we are going to use the same slot name every time. Now from this Doodle save game reference get high score variable, and here we are going to compare the high score with the current score. So get the score and check if it is greater than the highest score. So if this condition gets true, that means we have broken the existing highest score, so the current score is going to be our new highest score. So from the Doodle save game reference, we are going to set highest score variable, and our new high score is going to be this current high score value. So after we make any change in the variable inside the save game, then we have to make sure that we save that data. And to save that data, we are going to save game to slot. And here just use the same slot name that we used here while loading the save game, that is slot 1. So once we set the highest score value, then we need to provide that value here for this UI. And for the conversion, we are going to use this toText node since it already has all the things set up. So just plug the high score value here and give it as a text into this UI. Okay, so now let's play and test this. So first let's score a little bit. And now as the player falls and the game gets over, you can see we have set the new high score value. And if we play again and then fell off again, then you can see it still stores the highest score value. Now even if we restart the game, then you can see it still stores the highest score value since it is stored in the local memory. Okay, so now let me show you something. Like if the player goes the sideways, then the player will just go out of the view and will fall off out of the map. So what we are going to do is, we are going to add a horizontal side loop where if the player exits from one side, then he will enter from the another. And to do that, let's go to your background BP. And here, just like we add these collision box at the bottom and the top, the same way we are going to add box collision on the sideways. So from here, add box collision, and let's name this one left box. Place it to the left side and place it long enough so that it covers the whole left side. Now duplicate this box, and this is going to be right box, and place it to the right side. Okay, so now what you want is, let's say if the player overlaps with this right box, then we are going to set the player location to where the left box is. And the same way, if the player overlaps with the left box, then we are going to set the player location to the right box. So this way it will create a side loop and the player will never fall out of the map. Okay, so now for this right box, let's add a onComponentBegin overlap. So this event is going to fire when any object overlaps with the right box. So here check if the overlapped actor has the tag and the tag name is character, so that we will ensure that the object that overlaps with this box is our character. So once the player overlaps with the right box, then we are going to set actor location for this other actor. And here right click and split the structure, since we only want to change the location in the x-axis and the y and z axis can remain same. So from the other actor reference, get actor location, split the structure and connect y to y and z to z, so that these axis value remain same and we only need to change the x-axis. And now we are going to get the x-axis value from the left box. So get its actor location, split the structure, and we can use its x-axis to set our character's location to the left box. So if the player overlaps with the left box, then he is going to teleport to the right box. But this can actually create an infinite loop, since just like we add an overlap event for the left box, the same way we are going to add for the right box. And if we overlap with the right box, it's going to teleport the player to the left box. So this can result in an infinite loop, and to avoid that situation, what we are going to do is, when we teleport to the other side, then we are going to bring the player slightly away from the collision box so that it doesn't collide with the box as soon as we teleport the player, and this will avoid the infinite loop issue. So to slightly shift the position, what we are going to do is, let's recombine this structure. Here we are going to add this world location so that we can shift the player slightly forward. Now from the left box, get forward vector. So since the x-axis is considered as the forward direction, so we are going to add some forward actor value into the location of this box collision to shift the player slightly forward. So now multiply this forward vector, and here let's convert this to float value, since we are going to move 50 units away in the forward direction, and that's the value we are going to add to the x-axis of the left box. So this is how we are going to teleport the player when he overlaps with the right box. And now we have to do almost the same with the left box. So get the overlap event for it and just copy all these nodes, since we are just going to do a minor change to just teleport to the other side. So here instead of the left box, we are going to teleport to the right box. And here set this value to be negative, since the player is going to shift to the opposite side. Okay, so now let's see if the side loop works or not. So here as you can see, if we exit from one side, it enters from the other side. So yeah, it is working. And you can always adjust these values and also the placement of these blocks so that the teleport looks perfect. Alright, so now it's time to add sound effects in the game. And you can download sound effects from any website. Like I'm going to download sound effects from Pixabay. So it's a website where you find a lot of sound effects for your game. So here come to the sound effects section. So the first sound effect that I need is the jump sound. So let's check this one. So yeah, this is the sound that we are going to use every time our player jumps from the platform. Make sure to download it. And the next sound effect we need is the whistle slide down. Here it is. So yeah, this is the sound effect that we are going to use when the player falls down. And the next sound effect I'm going to use is wood crack. Here it is. Now we are going to use this specific segment from this sound effect when the player lands on the breakable platform and the platform breaks. Just make sure you downloaded all the sound effects. And for this one, we have to extract that part from the audio. So what I'm going to do is, let's drag this sound effect to the Audacity and just trim the parts that we don't need. So now it's just this wood cracking audio. So just extract this, and that is what we are going to use in the game. So now I have all the sound effects ready, and now in the project, let's make a new folder, name this SFX, and inside this, we are going to drag all the sound effects that we have. Alright, so now first of all, let's go to your background BP. And here, when the player overlaps with this min box, that means the player is falling, and that's when we are going to play the fall sound. So here on the min box overlap event, just make some space, search for play sound 2D. And here select the fall sound. You can also browse it from content browser, select it and pick it here. So now when the player falls down, it is going to play the fall sound. And now for the jump sound effect, just go to your character blueprint. And here in this normal platform overlap event, which is going to fire as soon as you land on the normal platform. So this is where we are going to play the jump sound effect just after the player has jumped. So here search for play sound 2D, and we are going to select this jump sound from the content browser and pick it here. And the same way on this breakable platform overlaps, when the breakable platform breaks, that's when we are going to play the sound effect of the cracking wood. So just pick that sound here, and that's it. You can add more sound effects in the game if you want, but I think these are enough. And now let's play and test this. So the sound effects are also working fine. Now if you're making this game for mobile devices, then you need to add gyroscope in order to move the character based on your device movement. So for that, in your character blueprint, as you can see here, currently we just control the character with our movement inputs like WASD keys. So for the gyroscope, we are going to use event tick, which runs every frame, and every frame we are going to track the movement of the mobile device so that we can move the character according to the device movement. So we also want this code to run simultaneously, so use sequence. And for the character movement, we can use this add movement input node. And here in the world direction, give the x-axis value 1 because we want to move the character in the x-axis, which will be horizontal movement. And for the scale value, here get player controller, and from the player controller, get input motion state. So with this node, we can get the motion data of the device, and here specifically we need the tilt value. Now right click and split the structure since we just want the z-axis of the tilt. Now let's multiply this value with, let's say, -4. So I have tested this value, it works fine with the mobile movement, but you can always experiment with this value since it handles the sensitivity of the gyroscope. And just like here we call this event after every character movement, so we are going to call that event here too, so that the character will face in the same direction where it is moving. And since this is based on the physical movement of the device, so we cannot test this in the PC, but this will work in your mobile device for sure. Now we are done with making this game, and now if you want to package this game for your Android device, then I will suggest you to watch a different video for packaging games for Android, since there is a lot of stuff you have to do for that, but still I'm going to give you an overview on how you can package your game for your Android. So first of all, in your project settings, in the packaging section, go to advanced and scroll down until you find this list of maps to include in the package build, and here you have to list your map from the content browser that you want to include in your game, which is the play map in our project. And also you can check this exclude editor content when cooking, so this is going to compress your game file. And then you can set this build configuration to shipping if you are planning to publish this game anywhere, or you can just set it to development if you are just planning to test this game. Also check this full build option, and then from the platforms, just uncheck all the platforms except Android so that the packaging will be more faster. And then just come to your Android section, and here just click on configure now. And now we need to give it the package name. So at this part, give it the game name, and here you need to give it your company name or whatever your publishing name is. And here you need to give it the application display name. So I want to show this game as Doodle Jump. So I want to show this game name as Doodle Jump. And here you need to give it the target SDK version. So we are going to give it 36, which is for Android version 16. And also you have to check this option to package your game into APK file. Although if you want to publish this game in an app store, it doesn't require APK but the AAB file. So you can check this if you want APK file. And now scroll down, and here in the orientation, make sure to select this to portrait since we want this game orientation in portrait, as in the vertical position of the mobile. And from this option, you can generate AAB file, which is required by App Store to publish your game. And there are still a lot of options that you can explore. Like from here, you can change the logo of your game, but the main options I have covered already. Now come to Android SDK category. And this is where you have to provide all your SDK, NDK and JDK files, which are required to package your game. And to get these files, you need to have Android Studio, inside which you have to download all those Android development related files. So here you can take the overview of how I have installed all these files. And after installing those files from the Android Studio, you just have to pick those files from here. Like here, I'm using NDK 27.2.1 and the JDK version 17. So once you selected all your files here, then you can proceed to package your project for Android. Now I still recommend you to watch a separate detailed video for packaging your Unreal Engine project to Android, since this was just an overview. And now we are done making this game. Now if you really appreciate my efforts into making this whole 2D platformer game tutorial series, then you can consider supporting me on Patreon, so that I can continue keep making such more game series in the future with the support of you guys. So the link will be in the description, and make sure to like and subscribe to my YouTube channel And I want to thank Patreon members of this month. Thank you so much for your support. It really means a lot. Alright, till then, see you. Bye bye.